exactly is air pollution? If we are reading as it is here, a definition by the World Health Organization, air pollution is a contamination of indoor or outdoor environment by any chemical, physical or biological agent that modifies the natural characteristics of the environment, of the atmosphere. That is just what air pollution is. When the natural constituent of air begin to be altered, change maybe in the natural structure or the amount of components that are supposed to be in that air, then we start talking about air pollution. Okay, we are talking of change in physical, chemical, or biological component. What exactly does clean air, what is it made of? We see that it's made up of 78% nitrogen, followed by oxygen 21%. We have carbon dioxide 0.04%. We have argon, and we have other constituents like neon in negligible amount, but it's there. So when you now begin to have some foreign particles introduced to air, then we start looking at air pollution. But we are just going to go directly to look at the pollutants, the various types of pollutants that exist. And here you see summarized and classified into primary pollutants and secondary pollutants. There is also another type of pollutants classified as hazardous air pollutants or toxic pollutants. But these are the major types, primary and secondary air pollutants. Since we are going to see them in details, there's no need talking much about them here. Alright, what exactly are primary pollutants? Primary pollutants are simply those pollutants that are emitted directly from their sources. That is, there is no change in the chemical composition. As they are emitted from their sources, they just pollute the environment. And these are some here. Looking at this chart, you see that about 46.2% of pollutants come from the transport sector. We now begin to talk of other stationary sources like burning of fossil fuel, as she was saying, industries contributing 15%, and then waste. The waste we even see more contributes just 2.5% of air pollutants in the atmosphere. So, like Mr. Harrison said, this is actually where, if we want to target air pollution, we should start. It's not like we are neglecting others, but we should start from where the impact is really much. Next slide. Alright, what are sources of these primary air pollutants? Can we just name them? The sources of primary air pollutants, based on what we know, of course, they are there. Can we just name them? Are you seeing? It's not really clear.
Yeah. The color is red.
Oh, sorry about that. But then, looking at the definition, I think if we are all here, we should know. Can we just randomly list some of those primary sources of air pollutants? Yes? I didn't get it. Alright, yes? Yes? Where's Melissa? You confused me with French.
I'm here.
Alright, can you just maybe tell me some? I know I'm dealing with experts, that's why I'm just playing around anyhow. Some primary sources of, some sources of primary air pollutants. Alright, from cars and the rest. Alright, natural sources, you have natural sources there. You have volcanic eruption, wildfires, ocean spray, dust storm, lightning. Those are all sources of primary natural sources of primary pollutants. Then we have anthropogenic sources, of course, sources, human-made sources. That's where we begin to talk of industries, traffics, maybe crop residues, and many more. These are actually the sources of primary. Many others might exist, but looking at them, I don't really see the ones that are left out, except maybe other experts are going to tell me more about that. All right, next. All right, just look at these pictures. Your volcanic eruptions, wildfires, we listed them there already. I just want you to reflect on this. Are we here? Just look at it. Do you think natural sources of pollutants are also a problem? Why not? We have just seen natural sources of air pollutants. What are some of the natural sources of air pollutants we just saw behind? What are some of the natural sources of air pollutants we just saw behind? Alright, good. So I'm now asking, do we really think that the pollutants from these sources are really a problem?
Yeah.
Okay, he doesn't know. Who thinks that is not a problem? Alright, everybody believes that and knows that it's a problem. Of course it's a problem. They are just sources of the same pollutants. It's not like the pollutants they emit or behave or have different chemical or properties. So they are also a problem, of course. That was strong. I will not want to call Pamela this period. I think Mr. Harrison can testify. Do you think the quantity of dust in Ghana can be compared with any other city in Cameroon? I don't think so. Sure. Is that true? It's not possible. Alright. That's a special case. Now that rates are falling, we are happy. Next slide. Okay.
Okay, just a kind of thought, or maybe reflection. If looking at the natural sources of natural sources of pollutant, like look at something like volcanic eruption. You know, you cannot control volcanic eruption. Maybe dust storm that happens in the Sahara that we are called Nigeria or in the west of Africa. Since they are natural, do you think that what can we do if they are natural?
The next slide answer that question. You look at here I just did a little bit of comparison between natural sources and human sources, and I did that under 3 factors. That is the duration, control, and impact. The very first one, natural sources are temporal, and human sources are continuous. There is never a day you will get up and then you don't see bike men on the street there. They're hustling. But if maybe a mountain erupts now, it might take hundreds of years. Maybe if it will ever repeat itself. That's just the very first one. Control. Natural sources are self-controlled. Humans cannot control them. They just regulate themselves automatically. But then, human sources can be reduced, of course, with policies. Us sitting here is because we want to look at how possible we can reduce human sources. We cannot be talking of natural sources here. Since natural sources are self-regulatory, let's handle the human sources. Of course, natural sources will handle themselves. What is actually killing us? What is causing our air to be polluted every day is, of course, 92 or 99% human sources and not actually natural sources. The impact can be severe but often short-lived. Still falls back to control. Long-term and cumulative health, environmental impact. Human sources, like we already established, is continuous. Every day, PM 2.5, 10, 1, cars are emitting it on the streets of Douala. Next slide. I don't, it's your...
Yeah, it's okay.
All right. Okay. What then are secondary sources? Secondary sources of air pollutants are simply, what then are secondary pollutants? Secondary pollutants are simply those pollutants that are formed in the atmosphere, and they are not emitted directly from any specific source. They are as a result of primary pollutants. And you see, secondary pollutants exist as combined as molecules, because it is due to some chemical reactions in the atmosphere. You have the ozone, sulfuric acid, nitric acid, PM 2.5, and what you see there. This picture actually shows it. That when cars emit it, when other natural sources here emit it, it comes, and in here you have some chemical reactions that we'll see ahead, and the result are often secondary pollutants. As we go ahead, we are going to see some simple differences between the two. Next slide. All right, formation of secondary pollutants. Photodissociation, that's the very first one that I decided. It's not like it's the very first one that is formed, the very first one I decided to talk on. Photodissociation of nitrogen dioxide. Photodissociation simply means that the nitrogen dioxide breaks down in the presence of UV light. When it breaks down, you have nitrogen oxide plus oxide, and that oxide picks up a molecule of oxygen, and you end up with ozone. Of course, we know what it does to our environment. You have formation of acid rain, being it through sulfuric acid or nitric acid. Those are the equations there. Pans formation. That is actually the equation there. If you are interested, you look at it carefully. Particulate matters. I just took two to show how when the sulfuric acid reacts with ammonia, it gives one of those particulate matters. Even though the harmfulness of pollutant depends on various factors like concentration, duration, and the rest, secondary pollutants are more dangerous than primary pollutants. This is not to say that primary pollutants are not dangerous. We are just comparing two things. And the very first reason is because they are highly reactive and toxic, extremely more toxic than primary pollutants. And they travel long distances, much more than secondary pollutants. You can have other things. Now, how can we now regulate secondary pollutants if we cannot handle the sources directly? How can we regulate it? Who thinks there's a way? Who thinks there's a way we can regulate secondary pollutants? Yes, please, not you for now. Please. All right.
From what you said earlier, you said secondary pollutants come as a result of primary pollutants.
Yeah.
So if you can try to, first of all, try to regulate primary pollutants, then automatically we are going to regulate secondary pollutants.
Marilyn, please add in a bottle of water here. I think he deserves one more. I think that is just it. Is there anything different from that? Are you thinking of something else? Because that's what I have. That's the answer I have. Maybe somebody has another answer. Different from what, or first of all, you got what he said. You got what he said?
Yes.
Alright. So, is there any other means, any other way we can regulate secondary pollutants directly rather than passing through primary pollutants? Alright, nobody's saying anything, it means there's no other way. So that is it. Next slide. Oh, it means the red color I use is not the best. Yeah? Well, note, here we just want to establish the fact that there are actually some greenhouse gases that are not really pollutants to an extent, like water vapor. Water vapor generally we know as a greenhouse gas, right? But then it's not really a pollutant, except maybe somebody have something else. But that is what I found out. And we have other pollutants that are also greenhouse gases, like carbon dioxide, methane. We have pollutants that directly affects air quality and climate. I mean, when I talk of directly, we are talking about ozone, we are talking about soot, black carbon. When I talk of directly, it means they do not react with anything to form something that then affects the climate. They themselves affect the climate directly. Do you get the difference? So that is, this one is just to establish that fact. It's nothing much about. That's just facts. That's just knowledge. All right. What do you think? Oh, okay. What do you think is the leading cause of death among Cameroonians? We have experts in that field here. Or even if not, what do you think generally is really killing Cameroonians?
Malnutrition.
Wow. Malnutrition. Yeah, I think does it fall in hunger, malnutrition, air pollution. So at this, even if we end here now, will you really still think air pollution is not worth targeting? It's worth targeting. Alright, next slide. Now, let's just look at this. How many people die from air pollution each year? We'll start with the WHO's data. Globally, they said about 7 million people, 4.2 million were as a result of indoor air pollution, and rather 4.2 million was as a result of outdoor air pollution, and then 3.8 million as a result of indoor air pollution. When we talk of indoor, outdoor, you understand, right? Is there anybody that doesn't understand that? Alright. Then, another statistics by Institute for Health, Metric and Evaluation said globally they had 6.7 million, 4 million, 4.5 million, and then 2.3. But then another data said they are 8.8 million. So when you take the average of these, you see that it centers around the 7 million. So with all this data, will you still have a doubt with the World Health data? So it means actually over 7 million people died each year. Now, because when I was discussing, I said I spoke about the concentration. I know that I think Mr. Harrison is going to really handle this part more, but for the sake of our understanding, let's look at it. This data is from the air quality guideline, and if I should start from here, air quality guideline said particulate matter 2.5. Particulate matter 2.5. Actually, they divided it because they knew that some countries are more exposed to polluted air than others. So what they did was, after doing all the calculations, they took what will be what we quantify as, is it 10? Yes, you should have air quality of 15. That's annually. But then within 24 hours, you should. Alright, it's not with me. So what I'm saying is, we want to determine the concentration of all the particulate matter in. Alright, we want to determine the concentration of all the particulate matter in air, and we know that particulate matters or pollutants generally are divided. We have many of them. That is particulate matter, where you have particulate matter 1, 2.5, but we'll be dealing with 2.5. We have nitrogen dioxide, we have carbon monoxide, and sulfur dioxide, ozone. But all of these have different concentration in polluted air. That is to say, we can have air, a polluted air in this room, which is more of particulate matter 2.5, and a polluted air in the next room, which is more of let's say nitrogen dioxide. A polluted air in the next room, which is more of particulate matter 10. You understand? So all of these have various effects, though they affect the health generally. Wow, thank you so much. You can now see, right? This is actually the air quality guideline for pollutants. Particulate matter 2.5 microgram per cubic meter. If you are breathing air with air quality 5 for particulate matter 2.5, then the air is good. The air quality is good. But if you're breathing, let's say, an air with particulate matter 50, air quality guideline 15 for 2.5 per hour, rather per day, you have up to 15, then it is still good. You understand? But World Health Organization said, if you are living in a very polluted environment and you have what they said the term interim targets. Interim targets are just potential targets. Like he already made mention that for you to improve on something, you should at least know what it is. So if you measure your air and discover that it has particulate matter 2.5, it has a quantity of 35 microgram per cubic meter, then it is not really the best. So it means that if you are breathing air with this quantity of particulate matter throughout the year, you are not really doing good to yourself. But if you are breathing this air with particulate matter 75 for one day, you are not actually doing good for yourself. But then they are saying that you can be managing while looking for ways to bring down this concentration. So when you are breathing air with this quantity of particulate matter inside, you should be targeting to reduce it at least to interim target 25 annually. So if your air initially had particulate matter 2.5, 35 microgram per cubic meter for maybe last year, you should be breathing it while working on reducing it to 25 annually. So if you breathe air of 35 microgram per cubic meter last year, at least this year you should be at 25. Let's exaggerate it. You should be at 25, and you continue working so that the following year maybe you should be at 15. The next you should be at 10, and then finally you will start breathing clean air. So clean air at least should have particulate matter 2.5 of 5 microgram per cubic meter. Alright, it follows, if you have understood the explanation, it follows same here. You discover that air quality with PM 2.5, a clean air has PM 2.5 of 5 microgram per cubic meter. A PM 10 for clean air, in clean air, should be at most 15 for PM 10. It follows suit for ozone 45, nitrogen dioxide 1, 10. That is actually what should happen. So if you are breathing air with air quality different from this, then you are not doing any good to yourself at all. Is the table clear now? Anybody with any doubts? Maybe because of the terms I confused some people along the line. Have you understood, like, because you should understand this at least? Yes.
I have a worry here.
Wait.
For the presentation. Under pollutants.
Yes.
So there are many pollutants that are taken into consideration.
Alright.
Their concentration.
Air itself, polluted air itself can have all of these pollutants inside. You understand? But when you're measuring, each of them will have different concentration. It's like you take maybe water and kerosene, maybe and small kg, put all of them together. You can take maybe a liter of water, you take half liter of kerosene, you take maybe 0.25 liters of kg, you put. How many components do you have? You have 3 components, right? You have water, you have kg, and you have kerosene. You understand? All of various quantity. So, in a polluted air, it's possible that you can have PM 2.5, you can have PM 10, you can have ozone, you can have nitrogen dioxide, you can have others. But now, at what quantity is each of these pollutant? That's what we are looking at. So, in a very, very polluted air, you can have PM 2.5 of 35 microgram per cubic meter. You can have PM 10 of 70, still in that same air, microgram, ozone of 100. So, this one now, you see, annually here, you see, daily here. So, it means that the average air you breathe throughout the year had this quantity of PM 2.5. Do you understand? Throughout that year. So if you are breathing this type of air, then you are breathing polluted air. But then if you understand that you are here, you can start fighting. So that, because the lesser this value, the more, the cleaner the air. The higher the value, the more polluted the air becomes. So that's why WHO standard says that for good air, you should have PM 2.5 of 5 micrograms per cubic meter annually. Do you get it? Maybe when he comes up, he's going to go more.
Okay, let me just say something, because I understood that we're supposed to talk about these standards and all these things. And even the unit, you're saying that this microgram per meter cube, you have never understood what it is, actually. Microgram per meter cube simply means that in a cubic meter of air, this quantity of, for example, if you have 5 microgram per meter cube of particulate matter 10, it means that in a cubic meter of air, so you have a cubic meter that contains air, 5 microgram, the maximum amount of particulate matter that is supposed to be there is 5 microgram. And you know, 5 microgram is 10 to the minus 6 gram, which is 10 to the minus 9 kilogram. So you can imagine how small that is. So what he's trying to say is that this is air quality guideline by WHO. And they have already done epidemiological studies, the health impacts of the certain quantity of pollutant on the human health. And they've seen that the maximum quantity, maximum quantity that a human should be able to inhale within a certain period and be fine and not have a problem, it's 5 microgram per cubic meter annually. So in the course of the whole year, the maximum number of particulate matter that you should be able to inhale and be healthy is 5 microgram per cubic meter. That is what it actually means. And then this interim target he has explained very well. It means that, for example, countries that are developing, that industrializing, they need to take action to reduce annual particulate matter. But they are saying that while you are targeting this, you can start from 35 microgram per cubic meter. You take action and continuously reduce. It means that it's a space of development. Because it's very difficult to come to this. Very few countries even meet this. But this is the safe limit. 24 hours, for example, you see this 24 hours is 15. It means that in a 24-hour period, the maximum amount of particulate matter 2.5 that you can inhale should be 15. That's a safe limit. Above that, you're breathing unhealthy air, which affects every system in your body. Anyway, we'll get to maybe talking to some of those terms, and then the standards and the guidelines, then we'll see it. Yeah.
You know, while you were doing the presentation, I was trying to connect it to the NDCs.
Yeah.
So, emission guidelines, maybe these are the things that constitute carbon emissions. So, getting the emissions at that level is also helping very much in climate action.
Yeah, is that, you know, like for example, the sector air pollution, it's an air quality, is not an independent sector. Because what are the sources of those emissions? We saw it on the graph that a major sector is the transportation sector. And if you look at the NDC of Cameroon, there's a goal on the transportation sector. The government wants to reduce emission in the transport sector to a certain level. That's why there's even a policy on the importation of electric, yes, a policy on electric vehicles. That's one of the goals that the government has taken. But in that way, they are taking it, those actions will lead us to reduce this amount of pollution. You get it right? So maybe continue to solve that.
All right, the very first studies that was ever done on a particulate matter in Cameroon was done in these three towns: Bafoussam, Bamenda, and Yaoundé. And these were the concentration of PM 2.5 they had. This study was done in 2014 by Climate and Clean Air Coalition. They said in Bafoussam they had a concentration of 67 plus or minus simply means it can be more or less 14 microgram annually. So this was the quantity or the concentration of PM 2.5 in the air that the Bafoussam people were breathing in 2014. Follow suit for Bamenda and then Yaoundé.
So maybe we'll go now to the guidelines and look at the thing. Look at annually, was it 2 PM 2.5?
Yes.
So you see that the air quality guideline says 5. And then
if you look at the first incident says 35.
Let's look at the target. Let's look actually, because this is the target. This is okay. The first incident says 35, right? Yeah. But the goal is to get to 5.
Right. Yeah.
But this is actually what is in the guideline. So the goal is to get to 5. Now if you look at Yaoundé, this is Bafoussam. So it's, I mean, that's 5 times more than, that's 7 times more than the target, the air quality guideline of the WHO. So people, I think Douala should be here also. Douala should be 7 or 10 times. Okay. So this is, okay, this is Bafoussam, right? See, 60 plus or minus, means that this is the major error. And Bamenda, 132 compared to 5. We're trying to get to 5. And then in Bamenda is 132. And maybe Douala will be like 600. Bamenda is 132. If everyone is reasoning with us, so why do you get the reason why Bamenda is this high? Will be land use change or something?
Yeah, mostly.
Yeah, okay. I also depend on the, alright. So, because when they say annually, this is what they do. When they're doing this study, annually they take 20, like, the first one start with hourly. So they collect the concentration every hour. Then they get the 24-hour average. They take the average every month. then they use the average every month to get a 12-month period. That's when they come about with this annual concentration of 67. Since they have done it hourly, done it daily, done it monthly, and then taking the average for 12 months gives you this 67 per year annually.
Alright, just shift to this version.
Okay, this one now.
Yes. Alright. This was done by Global State of Clean Air. Yes, 2010 to 2020. And then here, when you look at it, bring it down to me. This is average for country, global average, World Health Interim 1, and World Health Guideline. So you look at the column. That for our country, the average was 40, still far above. Still far above. That was from 2010 right up to 2030. And there was an increase. It means that from the previous year, at least it was even better. But there was an increase of how many percent? 3%. It means it's getting worse as we go, as the years goes by. The air is becoming polluted. Next slide. Alright, I think humanity is like this, just about okay, it still talks about, we are now actually looking at the leading cause of death in Cameroon itself. And the first A there is the top causes of death in females. And B here, top causes of death in male. Can we see at least? Even those who go boost. Wow, that's good. Alright. Top causes of death in females. Death per 100,000 population, that is in 2021 in females, and this one is in male. Look at the first two in females. Lower respiratory infection, that is 64.6 death in 100,000 in that year. Next, stroke with 52. Look at here in male, 81. And then next, COVID. But then now that COVID is not, you can still just reverse it. Anyway, I'm not saying that you reverse, we'll look at the current data. The first two that way, directly related to what? Air quality. So this is actually our own situation. This is Cameroon's data in 2021. So it's not even malaria, though we think it's malaria. It's not really even malaria. And just let's look at this data. Okay, that is it. So it means that because all diseases affiliated to air quality, I think all of them are known. So only that sector alone contributes 35.7% of deaths that occurred in 2021. So only that particular sector. Can you imagine what we are? And now I want us to just look at this. Have you noticed any changes in weather patterns that could be linked to air pollution or air pollutants? Who have noticed any changes in weather pattern that could be linked to air pollution? If you have noticed anything, just let me know. Nobody have noticed any change in the weather pattern that could be linked to air pollutants? Yes.
That is 7th image.
1, 2, 3, 4, 5, 6, 7.
Yes.
This one.
I think it will be due to an increase in temperature.
Alright.
Yes.
Okay, noted. Who else? Who else? Tap. No. Can you just tap? Mommy. Alright. It's okay. I just wanted to call her back. Alright. Because you tap her now, have you noticed any? No, not you.
There's a hand that way.
Okay, there's a hand that way. Yes?
Okay, the wildfire.
The wildfire.
Because of climate change, global warming, the temperature, the average temperature of the earth is rising. So this cause the rising temperature that can maybe cause drought, and also just a small spark in the environment can cause wildfires. We don't really have it here, but I think that in America and Australia they experience a lot of wildfires.
Thank you so much. Now I want to ask, how did you know that it was linked to air pollutant?
The question still me.
How did you know? Because the question is, just bring it down. Yes. Look at the question. Have you noticed any changes in weather patterns that could be linked to air pollutant?
Yes. So,
yeah, and you said this, right?
no, I said wildfire.
Okay, you said wildfire.
Yes.
Now I want to ask you, how did you know that the cause was, the same question goes to you. How did you know that it was as a result of air pollutant?
So, I think that one of the air pollutants that we have is ozone. And the ozone layer it protects the Earth's atmosphere from sunlight. So, with the depletion of the ozone layer, this increases the temperature on the Earth's atmosphere. So, this can lead to wildfire. So, that's my relation to
Greenhouse gases can also cause that. So this one was just a question that would cause you to think. I don't know if you've forgotten what is there. All of these things are caused by maybe greenhouse gas emission, and some greenhouse gases are pollutants. So there is nothing that is specifically linked to air pollutant, because you cannot actually say that this one was as a result of this air pollutant that maybe is causing this particular climate change. I don't know if you've gotten the point. So this question is no. The answer to this is no. Because you cannot pinpoint. Even if maybe there is drought, yes, it's as a result of the accumulation of greenhouse gases in the atmosphere. And some greenhouse gases are pollutants, true. But can you say that this particular one that causes this drought is as a result of this greenhouse gas that is also a pollutant? Anyway, it's okay, thank you. Next slide. Alright, environmental impact. We've actually looked at the health impact. Now let's look at environmental impact. The very first one is acid rain. The formation of acid rain that results to leaching. When acid rain falls, it reacts with essential minerals in the soil, like magnesium, calcium. Of course, they exist as carbonate, and when that takes place, it wash away these chemicals from the soil, rendering them not fertile, and then also washing these heavy metals to our rivers around. And when they get to our rivers, even with the acidic rain, it increases the pH of our water system. And when the pH of our water bodies are increased, of course, what happens? It affects their aquatic life. So you see that if acid rain falls here, it's going to affect our food security, because when soil becomes infertile, our crops will not do well, because it's even going to kill the microorganisms that are living in the soil. And these heavy metals that will be broken down will be washed up with rain runoff to streams, changing the water pH. And the moment the pH increased, you begin to have situations like fish die, and yes, and even in forest, when plants lack these very important minerals, you see a change in color, because they will not have what it takes for them to be healthy. You see maybe a forest just become yellow because of lack of chemicals. You see, that is actually the equation. That is the equation, and this is the way your forest will become as a result of acid rain. And these hydrogen ion will be washed into lakes, and when they are washed into lakes together with the heavy metals, next slide, this is what you will see. And just imagine that all our fish and other aquatic life die as a result of the high pH. What will happen to us? What will happen to us? So that one is very, very, it's not good. Next slide. How it affects our climate directly. Like we already established, black carbon, ozone, hydrofluorocarbons, they directly affect our climates. Why? Because they have a very high global warming potential. Although they remain in the atmosphere for a very short while compared to carbon dioxide, but then they hit the environment at a faster rate. When they talk of global warming potential, they are just talking, they just refer to the ability of that particular greenhouse gas to heat up the environment. I think methane, is it methane? Methane have a global warming potential of, is it 28 to about 30 something? That is to say that if a kilogram of carbon dioxide can take the temperature of this room from, let's say, 0 to 1, then a kilogram of methane will take it to, that is 0 to 1 degrees, then a kilogram of methane will be able to take it from 0 to about maybe 28 or 32, I think thereabout degrees Celsius. But then carbon dioxide will remain in the atmosphere for a very long period of time. But methane, I think, has just a few days, or I think so. So it has a very short life in the atmosphere, but with a higher warming potential. Nitrogen dioxide, same. ozone safe. So that is how these superpollutants affect the environment directly. Reducing them can slow climate change quickly. How? Since they have a greater global warming potential, reducing them will actually reduce our temperature easier. You see, that is just a picture showing what will happen next. Next slide. Alright, more on our reality. We are running up. A report from State of Global Air Quality, State of Global Air in 2019 says that over 13,000 people in Cameroon died from air pollution related diseases. Over 13,000. Just look at something. Mark this one, 13,000 air pollution. And then in 2021, Biomed Central published another article, and they said that household air pollution alone caused approximately 11,400 premature deaths in Cameroon. Have you noticed something? Up here, they said air pollution caused 13,000 deaths. And then down here in 2021, this data was 2017. 13,000 people died from air pollution in Cameroon. But then in 2021, household air pollution, that is indoor air pollution, right, killed about 11,400 people. Who have noticed something? Sorry?
The number of deaths has increased.
Really? I think 13,000 is more than 11,000.
But the thing is that it is 13,000.
Can you tell us, it's not specify whether it is household or indoor air pollution?
That's exactly what I wanted you to see. And I want to use that to establish the fact that the case is worsening. Because if this number can die as a result of indoor alone, then what of those that actually was as a result of outdoor? You see that from 2017, we had 13,000 people. Then in 2021, maybe we'll have 19,000 or 18,000, I don't know. But maybe looking at the data. Alright. This was actually another study reporting this average concentration of, yeah, we saw that already. Then, this is the most recent data specifically about the Douala. I think it should be, because it was published in March this year. Are we just in March?
No.
So I think this is the most recent data. That is what he said. He said PM 2.5 is between 44 to 210 microgram per cubic meter, and then PM10 50 to 240 microgram per cubic meter. Around his studies was around these two places, Pure 3 and Pure 5. That's Carrefour, Noboti, and Carrefour PK14 there. Okay. I told you my face. Alright. QS5, this was his conclusion. He said in that Carrefour, the high concentration are actually caused by the phenomenon of resuspension brought on by the presence of unpaved roads. When he mentioned of resuspension, he was talking about dust that will rise, pollute, fall, rise again, and then keep doing the same thing. And then around Ndokoti, the high concentration is directly as a result of traffic. That is transport. But it's not like what this one, transport does not affect him. It was just from his studies, he saw that particular area, the principal cause at that time is as a result of this. Do you get that? Next slide.
Was it annual or?
Yes, it was annual because he started his studies, I think, when it was published. Alright. Cyril Mezoa in 2017, he also did another studies. Remember, we are doing some scientific review because, like he said, without data, we don't really understand where we are. He said carbon monoxide levels increased by a factor of 18 for a period of 2002 to 2015, with an increase of 65% in two-wheelers. Two-wheelers are bikes, and 31% in cars. So he estimated that by 2035, bikes are expected 533% and car owners by 146%. So with what is already existing, if we actually experience this increase with business as usual, how will it become? Alright, these two-wheelers alone are up to 78% responsible for poor urban air quality. That was according to his research. And I think we have reviewed enough. And this guy, he just concluded that the traffic situation, the aging of motorcycles, and the nature of the fuel revealed their influence on the emission of pollution by motorcyclists. So he is simply saying that the main source of air pollutant in Douala is actually the transport sector. That is just what he said in essence. Alright, now that's just it. Vehicular emission, the city dance. So this one is nothing short of repeating that the transport sector is leading, followed by the industry, and maybe we can begin to talk of waste. Remember, we are talking about Douala. So what can we do? That is actually the question. What can we do? What can we do is a question that I'm rounding off with. Begin to think, begin to answer that question within yourself. Clean air is actually not a privilege, but it is our right. So, what can we do? Thank you so much for listening and contributing. But then we are just going to use another 2 minutes, just 2 minutes, right? Yeah. If you have a question, a contribution, a doubt, anything, within these 2 minutes, please. Okay.
Thank you very much for your presentation. It's very resourceful and definitely has been pointed on the many difficulties and problems that people face definitely, which is not, they are not really aware of it. Air pollution actually, as the statistics present, the statistics presented by 2013 and 17 respectively, something shows that it's claiming the lives of so many people. But I will come back to the last phrase that you ended your presentation with. What can we do? I always believe on the solution-based issues than probably just presenting the issues. Now, it is somehow difficult or disheartening that up to around 2025 that we don't have any particular convention signed by the Cameroon government targeting pollution individually. They have signed so many protocols and so many conventions like the Kyoto Protocol, but all of them based mostly on climate change. I don't think there is any that talks about individually about pollution. And if we get statistics of people dying 11,000, 13,000 or whatsoever dying, and the state does not have anything that has to do with this, then definitely it's a major issue that we should think about. And here I'll permit me use the word we. Let's not say the state, let's use we as he has presented. What are we doing? I think it's a very key factor that we have to get to. Something should be done about pollution. What are we doing? States started signing about 1987 when the Montreal Protocol was signed to fight against pollution. But a state as ours, we don't have any. So probably I think the rest of the country is still at risk. No matter all the statistics are being presented, probably they don't have any impact on the country because we don't have any particular convention talking about fighting against pollution. So definitely we need to do something probably in order to curb all these difficulties that we have. Thank you.
Thank you so much for that input.
Yes, comment.
Yeah.
Thank you very much for the presentation. Based on the statistics that are given, is enough evidence for if there is a policy, the policy can really be set on high because there are a lot of policies, but the policy need a lot of vital evidence to push it up that it will remain at the table of the stakeholders. It's very enriching, and I believe all of us here we are becoming advocates of air pollution. Start speaking high and presenting on policy tables. I'm a policy student and I'm interested in the evidence, so I can.
Thank you so
really
much.
right on it. Thank you.
Thank you so much. Thank you so very much. So that we should not take a lot of time. Maybe if we have any question, we can always handle that in other sessions. Thank you so much for your presentation and I wish you all the best.
Okay, let's give a round of applause again to Mr. Rudolph. All right, thank you so much, Rudolph. That was really, you see, when it comes to air quality, the research is there. Maybe like looking at, because most of the research, when you look at the research on air pollution, sometimes it's not really localized to Cameroon. But we need to get to that level where we are doing our own research, getting the refact. For example, get up one day and there's a research link air quality to maybe hard dons in the city of Bamenda and all those kind of things, right? So, but that was really quite interesting. Thank you so much. And because we don't waste a lot of time again, we started very late, and I know some people have not introduced themselves. We'll just go to the next session. And I realized that when Mr. Rudolph was saying some things, I mean, people are getting lost because those terms are really important. They are very important for people to understand. So I'll just go directly into this session that I want to talk about. But before we go, some people joined us when we already started and we did an introduction. So maybe those who joined us and they are not introduce themselves, they just say their name and maybe their profession and the organization they are associated with so that we know. We do that for 1 minute. I'll start here. En français, what? Français ou anglais? Tout le monde comprend le français.
Désolée de mon air fatigué, on a voyagé toute la nuit. Voilà. Je m'appelle Bukolo Amanda, Marie-Georges. Je suis chargée des ressources humaines au rappel. Et l'association et je suis aussi je fais dans la santé.
Vous faites dans quoi? Assainissement.
La santé.
Ok, la santé.
Là, je suis pianiste. Auxiliaire de défense.
Bien, ok. Bonjour. Moi, c'est Labonga Steve, ingénieur général de formation, coordinateur général du réseau africain pour la promotion de l'éducation à l'environnement et de développement local. Merci.
Good morning. live and work in Yaoundé? As what?
18.
Okay, okay. All right. Doctor, I think you're the one that's going to do this way.
Good morning, everyone. First of all, I want to appreciate this gathering today. I'm Dr. Silas Nanikuku. I'm a medical doctor, specialist in cardiology. I'm the founder of Knowledge Gate Foundation, which is in charge of mental health issues to promote and to raise awareness. And also, I'm newly into, I don't know if it is ISEC or ISEC, but I'm newly a member in the group. So I'm happy to be here.
Okay, this way, is there any other person that joined? Hey, okay. No, I don't forget.
I'm called Benedicta Chamo. I'm a teacher, I'm a student at the same time. So at the end of this program, I said it's part of my interest. So I said let me come and learn something new. So that's why I'm here.
Okay, thank you very much. And this way, nobody. All right. So we continue. All right, let's talk some air quality terms. I'll be very brief. Like before, my name is Harris. Unit of measurement. Because air quality can be very complicated. You know, so look at also air quality index. This is something we can also look at emission limits as in standards, and maybe air quality monitoring and related terms. Because there's a session in the afternoon that will do some monitoring, and then we'll have a short exercise. I've got people already sleeping in the morning, which is not good. How do we even know that the air is polluted actually? How do we even know? You know, the thing is that air pollution is sometimes it feels so far-fetched that people cannot comprehend that the air is polluted. How do you know? Is the air really polluted? The air is really polluted. And we have seen from the statistics. That's why we're here also to measure, to understand why we say that the air is polluted, how it's polluted, and how we can understand the level of which it is polluted. This is a quote that got me thinking. It said there's so much pollution in the air now that if it went for our lungs, there will be no place to put it on. It means that our lungs receive the greatest chunk of the pollution. We've seen the statistics. Rudolph has related the impact. Now, research has already said, I'll not go again. This was the state of global air talked about pollution in general. So I'll not say anything again about this. This is a very global statistics. Now, I think Rudolph also said something about the atmospheric condition, the atmospheric composition. Normal, when they say something is polluted, it means that its normal composition has been altered. This water has a normal composition, H2O, 2 hydrogen of water and 2 hydrogen atom and 1 oxygen atom. If you alter that composition, it is polluted. That's what pollution is all about. So this is the normal atmospheric composition under normal circumstances. Now, if you alter this composition by just releasing something into it, it becomes polluted. So these are the normal gases. But he already said that nitrogen is the highest percentage, 78%, oxygen 21%, and all other gases you can see. So when we go now to releasing other gases into the atmosphere, we talk about pollution. That is what pollution is all about. And another thing is that atmospheric chemistry, the atmosphere is so dynamic. So the processes are so dynamic. Atmospheric condition, weather condition. So pollution, air pollution changes rapidly with weather conditions and all these things. That's why sometimes it is so complex that we need to reduce that complexity so that people can understand. If we alter this composition, we pollute the air. But now, how do we measure that pollution? What are the units of measurement? When we say well, because when you say this is the atmosphere, it has 100%, 78% is nitrogen. What does that even mean? 21% is oxygen. What does it mean in research? For example, this is 0.25 liter. Assuming that this is the atmosphere, what does this mean when you say 21%? It means that a certain quantity of it could be liters, 21% of it is oxygen, right? So how do we measure atmospheric composition or pollution? It's measured in concentration. So it's a quantity of air, because we have said that we have this composition. Now if you introduce an external quantity, for example, carbon dioxide, if you release it into the atmosphere, it alters that composition, it alters the concentration of that composition, which gives us air pollution. Now, how is air quality measured? The first thing is that it's measured in terms of concentration. For in the house, right, we cook. When we take water, we put on the fire and we put salt inside, normal sodium chloride. That's concentration. A certain quantity of a solid in a certain quantity of a solvent gives you concentration. Now, concentration-based measurement, it measures the amount of a pollutant in the atmosphere. I'll look at the first unit. The first unit that Rudolph talked about is micrograms per cubic meter. So all these pollutants that we are talking about, it measures the mass of a pollutant in a given quantity of air. So if you take this, let's assume that this is 1 cubic meter. The concentration of a pollutant here will measure the mass of that pollutant inside this 1 cubic meter of air. You know, air is a gas, right? But that pollutant, it has mass, it has weight. So you measure that mass. And microgram, like I said, microgram is so small. 1 microgram is 10 to the minus 6 grams. So 1 million microgram makes 1 gram. And 1 billion micrograms make 1 kilogram. You can see how small that is. That's the first unit. Just know that it means that this quantity, this is the mass. Microgram is mass of the pollutant. Meters cube is the volume of air. So for example, if you look at this, what does 35 microgram per cubic meter mean? Okay, let me talk about it. This PM 2.5. Nobody asked what PM 2.5 was. What can someone tell us what PM 2.5 is? But what does it actually mean? But yeah, particulate matter 2.5. What does that mean?
Particulate matter concentration is 2.5.
No. Okay. What? Okay. This PM is particulate matter. But this 2.5. What does it mean?
The concentration.
No, the size.
Someone should put their hand up and down. It's very important. Mr. Rudolph.
Diameter.
The diameter. So PM 2.5 is every particle that is less than or equal to 2.5 micrometer. Maybe I should have not explained. But it's important. PM 2.5, it means that every particle that is less than in size, they talk about diameter. Those particles you don't necessarily see with your naked eyes. So if the size is less than or equal to 2.5 micrometer, 2.5 micrometer is 10 to the minus 6 meter. That is the size. And then PM10 is the same thing. PM10 is any particle that is less than or equal to in size of 10 micrometer. So what does that mean? It means that PM 2.5 is PM10. You get a sense? Any particle that is less than or equal to 10 micrometer is PM10. It means that 2.5 is less than or equal to 10 micrometer. It means that PM 2.5 makes 2. It's part of PM10. Anyway, let me not go into that. There's even PM1, and it's not quite common. There's PM1. It's not quite common. So what does this mean? For example, particular matter level of 35 microgram per cubic meter, it means that in a cubic meter of air, so if you isolate a container and you put air inside, it means that the mass of particulate matter in that air is 35 micrograms. That's what it means. That is what it is important so that when we are doing any other thing, you see that is what it means. Now the next thing is, this is the first concentration based unit. The next is part per million. Carbon dioxide, when those who are dealing with climate change, they always say the carbon dioxide concentration increased from this 200 parts per million to 400 parts per million in less than 10 years. But what does part per million mean? Part per million, it simply means that it represents the number of molecules per 1 million molecules of air. So instead of taking out the grams, so you take, for example, if you take this container and you have 1 million molecules, if you say this container has 1 million molecules of air and 10 molecules is carbon dioxide, it means that the concentration of carbon dioxide in this air is 10 parts per million. I don't know if this makes some sense. Guys, nobody's talking. Chemistry is chemistry can be the way it is, right? So you notice this part per million when you talk about carbon dioxide and other things. For example, carbon dioxide concentration of 400 parts per million. It simply means that in a certain quantity of air, 400 parts is the concentration of carbon dioxide. So 400 parts per million. This is what it means. The next one is billion, parts per billion. What do part per billion mean? Can someone tell us? Parts per billion. This one was part per billion. So the concentration, for example, the concentration of ozone is 20 parts per billion. What does that mean? Yes?
Okay, so the number of molecules per 1 billion molecules of air.
Exactly! That is it. So between part per million and part per billion, which one is greater?
Billion.
Okay, let's go to part per million. Okay, you see, part per billion, similar to part per million, but measures pollutant at a smaller scale. If you take 1 million molecule and you have 200 molecules of carbon dioxide inside, and you take 1 billion molecule and you have 200 molecules of carbon dioxide, which one is greater? 1 million. Quantity. So this is what it means. And if you look at the units, the unit of measurement, it corresponds to particular pollutant. If you look at ozone, you will hardly see ozone measured in micrograms per cubic meter. Because the quantity, it tells you about the concentration of that pollutant in the atmosphere. If you look at particulate matter, you always see microgram per cubic meter. If you see ozone, you never see microgram per cubic meter. Which one is greater? 700 parts per million or 700 parts per billion? 700 parts per million. Very good. That is what it is. So, is this unit of air quality okay? So, what Rudolph was saying, that 5 micrograms per cubic meter, do we understand the air quality guideline? Do we know what it means now? That is what it is. Right? The next thing that we are going to talk about is air quality index. Now, air quality, look at something here. If you tell someone that the air in the atmosphere, the concentration of the atmosphere outside is 5 micrograms per cube, they don't understand what that is. Physically, to comprehend it, to help, it doesn't make sense to a normal person. It makes sense to people who have scientists. It makes sense to us goers. But a normal man in the society doesn't know what that is. So that's why they came out with this, the US Environmental Protection Agency came out with this air quality index. It actually gives us a coherent way of advising the public about the state of the air. whether if the air is unhealthy, is healthy, or is so because common people cannot understand, the general public cannot understand this concentration thing. So air quality index comes to unify that concentration to give it in a way that a common man will actually understand. That's why they say that it is a standardized scale that converts pollutant concentration into a number. So convert all this pollutant concentration into a number between 0 and 500. And each of these signify if the air is healthy or not. This is very understand. So this you classify from 0 to 500 a scale, and then it's either from good to hazardous. So as the number is increasing, it's going from good to very hazardous. For example, the air quality index in this room now. If I tell you that the concentration is of PM 2.5 here is 25 micrograms per cubic meter, you don't know what that is. You don't know. But if I tell you that the air index, the air quality index here is 55, you know that is this. So let's go to the next thing. And the truth is, the thing with air quality is that it varies globally. Cameroon does not have a unique, like their own. So we adopt that of the US. The country like China, they have their own. Country like India, because pollution is a serious issue there. Now you can see, we said that the number is from 0 to 50, 0 to 500. It means that from 0 to 50, you consider the air quality as good. From 51 to 100, you consider the air as moderate. From 101 to 150, you consider it as unhealthy for sensitive groups. Sensitive groups are people who have maybe pre-existing conditions, asthma, asthmatic, and all these health. Our doctors are here. They can know these things. And then from 120, 151 to 200 is very unhealthy. It's unhealthy. From 201 to 300 is very unhealthy. From 301 to 500 is hazardous. So, can you make a comparison between those concentration things and this air quality index? Which one can a common man in society comprehend more? So there's this scale. It's easier for, so this one is generally for public health, for the public to be able to understand that the air is polluted. Because when you start taking the concentration, nobody understands. That's what it is. So if you see detailedly, we have this, right? So this is still the same thing. This is the color 50, air quality is good. Precautions to take. No, everyone can enjoy outdoor activities. So if your air quality index is 0 to 50, you can enjoy any outdoor activity. It also goes to indoor. Let's look at this indoor air quality now. Index 59. What does it say? It's moderate. And it says that air quality is a concern for people who are extra sensitive to air pollution. There are people who are extra sensitive to air pollution. So the air quality index is like this. And you should know that this air quality index of this level, it goes back to a certain concentration of a pollutant, which you already know. So maybe people extra sensitive to air pollution should not plan any strenuous activity outside. Now you go now to 150, we said it's unhealthy. This one, air quality is unhealthy for people, including active adults, people with lung disease, including asthma, blah, blah, blah. So are you seeing that this is what it is? This now makes air pollution understandable by a common man in the society. Now, a question I'll ask is, what is the difference between air quality and air quality index? Can someone answer? Air quality. What is the difference between air quality and air quality index? Yes, maybe.
Air quality is a state, maybe good, the air quality can be good, bad, maybe moderate. And the air quality index are those ranges of values that we can be able to do comparative analysis of our state.
You know that the air quality index, it gives you a scale that tells you, that categorizes the air from good to hazardous, right? So what you have said is air quality index. Who can try again?
She has just reversed.
Yes, exactly. Let's go. Air quality quality is the amount of pollutant in a unit volume of air. While air quality index is a measure of pollution as a unified index, right? Across all pollutants. You can see the typical unit. Air quality is measured in micrograms per cubic. Does air quality index have any unit? It has no unit. But it's a unified index. I'll show the formula there, but we're not interested in the formula. But it has a complex process of actually evaluating it. They do some modeling and all those things. Is it better to report pollutant concentrations or pollutant air quality? Who again?
It depends on the purpose and the target.
Okay.
If we are talking to a layman like us,
Yeah.
we know we are learning.
Yeah.
We are learning from scratch. We want to learn. The air quality index is really ideal since with the colors you exactly know the colors give a kind of feeling. With the red, you know that is an alert.
Yeah.
Green is good. Now, when you are dealing with research and when we are dealing with policymakers and you want to take key decisions, you need the real values because the index also fluctuates according to schools. There is the EPA standard, there is the WHO standard. EPA is
Environmental Protection
Agency, exactly. So they have their way of calculating the limit rate per day. It's not even the same with WHO. So they have their way of calculating their standard. So now if you want to take key decisions, somebody had a nice comment in the beginning. They were saying that how come the government is not yet taking action in that? It's because we lack data.
Yeah.
So if we sample the air, if we have data, we can now go to tell them that, okay, this is the quality of the air that we have noticed since a certain time. And now people can take action. To take those actions, you need concrete data. You cannot just work with colors. It's not scientific. So you need those data to make calculation and to make also projections in order to understand the impact of this air quality on your life, the reduction of your life expectancy or health, and so on and so forth. Thank you.
Okay, thank you so much of what it is. Now, like she said, value, air quality, and maybe the air quality index. For someone, an academic person, the person needs the value. And then maybe for non-governmental organizations, they want to raise awareness, they can depend on the index. To follow strict standards, they need the value. Index doesn't really mean something to them, but they need the value. For a parent, all of us here, parents, what do you need? You need the index. And then for the media needs the index. So it depends on the person you are talking to, the answer varies significantly. The index, how is it calculated? Anyway, I'll not say anything about it because the calculation depends on different organizations and all those things. But it's just some complicated formula that we're not interested in now. So, now the next thing I'll talk about, because at the end of the day, we've mentioned here that for air pollution or emission limits, the reason why that has not exist, or maybe, but I think the ministry is currently developing something, a national standard for Cameroon. Because before they start coming to say that, and trust me, getting air quality data is expensive. It's very expensive. So the government needs to invest a lot in that, and we also need a lot of research to go into it. For example, this thing is about, I think it's about 300,000. This is about 300,000. The outdoor, but this is an indoor monitor. Outdoor monitor, you buy and ship to Cameroon, it's about 500, 600,000. Melissa, they can best tell you how expensive these things are. So it's really expensive. So they need that can be emitted from a source over a given period. Who's produce gases within this limit. And there are environmental officers that go around check all these things all the time. If it in a normal society, in a same society, if it is not like that, because I don't know, but that is how it actually works. So there are specific industries, for example, that produce a lot of sulfur dioxide. And I don't know, Rudolph did not say this, but when it comes to air pollutant, there's something they call criteria pollutants, and there are 6 of them. Criteria pollutants, you have particulate matter, PM10 and PM2.5. You have sulfur dioxide, you have nitrogen dioxide, you have lead is there, and we have, there are 6. How many have I mentioned? 6. So those are 6. Carbon dioxide also is a criteria pollutant. So it's every regulatory agency, they take this one very seriously. Why they call it criteria pollutant is that a lot of studies have been done and they show that these pollutants they have the highest health effect. Maybe we are taking examples maybe from the US, but that's where even air pollution even started very seriously. So that is what it is. And then I'm giving an example here saying that a diesel vehicle may have a nitrogen oxide emission limit of 0.0 grams per kilometer. Can someone explain to me what this means? Can someone just explain? If a diesel vehicle, because a diesel, there's all these things, internal combustion engine in general. If a diesel vehicle has an NO, it's NO is nitrogen dioxide emission limit of 0.08 grams per kilometer, what does this mean? That's a limit.
That is, in every kilometer that the car covers, the car should not emit more than 0.08.
Exactly. It means that in every kilometer that the car covers, it should not emit more than 0.08 grams. And this 0.08 grams is so much. That's why maybe in some countries like Europe, because of this, they need to have catalytic converters in the exhaust. Right? So these things are really important. Another thing will be a coal power may have a sulfur dioxide emission limit of 400 milligrams per cubic meter. What does that mean? Who can tell us what that means? That's a limit for a coal power plant. I don't think we have a coal power plant here in Cameroon. I'm not sure, but what does this mean? Can someone tell us what this means? That's a limit. What does it? Remember, this is when I say this is concentration. It means that the amount of sulfur dioxide that is emitted per cubic meter of emission of air that's going out from that start in the industry, it should not be more than 400 milligrams. That's what it is. So if you've noticed, each pollutant has its corresponding unit and its corresponding language. You don't take parts per million and you go and talk about particulate matter, because those concentrations vary and their meaning vary also. So that's why I'm taking time to really explain some of these things. This is emission limits. The first thing is that it's the maximum allowable amount of a specific pollutant that can be emitted from a given source over a given period of time. Now, emission standards. What are emission standards? Now we talk about limits and standards. Standard now is a regulatory framework. A regulatory framework that sets pollution requirements for entire sectors, not just for a particular source. So emission standards is a regulatory framework that sets pollution requirements for entire category of sources. It could be industries, it could be power plants, it could be vehicles, right? So it's a regulatory framework, that's standard. For example, we talk about the World Health Organization air quality standards. Those standards are what? Regulatory framework. It sets emission limits for whole sectors, not just for one particular pollutant or source. Then now when it comes to limit, in the country of Cameroon, they have a limit on sulfur dioxide emission from a particular source. I don't know if we are making it clear. So most of the time, standards define technology requirements. They have performance-based limits. ET, maximum emission per unit of production. Okay, so how how is emission standards applied? The first thing is that they set a national or international levels to regulate sectors like whole sectors, like the transportation sector, the energy sector. They also enforce industrial permits, vehicle certification, and environmental laws. So standards are what enforce environmental laws. The next thing is they are developed by global organization. What Cameroon does is limit, we set limit, we don't set standard. So WHO, US, EPA, EU, ISO, all those things. This is an example of a standard. Anyway, check for standard that correspond to, that would make sense in Cameroon. But since some of us go to Europe and know what it is, they say the Euro 6 standard sets emission limits for cars in Europe, requiring diesel vehicles to emit NOx below 0.08 grams per kilometer. This is a standard in the EU, and I know we all know what this means. These standards are very strict in Europe. I don't know if you go to London, there's what they call ultra low emission zone in London. It means that there are places that cars cannot go into it. There are ultra low emission zones. Because the pollution of those areas were so high, and they set these standards to control those emissions from particular sectors. They say, okay, they set this zone, ultra low emission zones. If you want to go there with a particular car, you pay a tax. And do we know what this tax is? In Cameroon, how is this tax called? They say environmental tax in Cameroon. Pollute and pay principle. Principe de quoi? Polluer, payer. You pollute and you. That's the same thing. Maybe you don't apply, but for example, these bottles. According to the principle of pollute and pay, normally this company, they need to manage this bottle. Are we applying the law? Are we applying it? Let me just digress a bit. In Europe, in Germany in particular, right? In Germany in particular, this is, let me show you how a standard or a small law has changed. You walk in Germany, you will not see plastic bottles. You can see another thing, but you will not see plastic bottles. Because what? Because there is, when you buy this water, there's a tax that they have put on this water, an extra, they call it food. So recycling tax, there's an extra 50 cents that you pay for this water. So this water is €1, you pay €1.50. Then when you bring that €1.50, that 50 cents, extra 50 is for the company to manage it. When you bring back the bottle, they give you back a 50 cents. Germany is only paying €1 and there are no plastic bottles. And they are trained and people are picking this. And it's a living. You get it right? So that's, I'm saying a lot of things, right? Emission standards. So we're just trying to digress a bit to emission limits. So we can summarize the difference between emission limits and emission standards. Look at the scope. Emission limit applies to individual sources, while emission standards applies across sectors, the transportation sector, the energy sector, and then regulation level, emission limits define permits of factories, vehicles, etc. Emission standards set by governments or global bodies. Flexibility, emission limits can vary by region, industry, or company. So a particular company might have a particular, for example, maybe the cement industry might have a particular limit of the same pollutant, while another industry might have a different limit of the same pollutant. That's what they call flexibility here. And then enforcement, you can see, that is what it is. So I don't know if these terms are too technical, but I really want us to get some of these concepts. The next thing I will look at now is air quality monitoring, what that is. Understood standard limits, because we need to get data to understand the state of the air, or maybe to see if policies are being violated. How do we get the data? We need to monitor the data. And what is monitoring the data? Because there will be a session on air quality monitoring. We need to know what that is. This AI, this thing AI generated, ChatGPT. This is a Cameroonian measuring air quality. so polluted and he's measuring. It's a good thing now. So, what is air quality? It's a process of measuring and assessing pollutants in the air to determine, we have said it, their concentration. Because not just determine concentration, their sources, and the impact on human health and the environment. And there's nothing more to say about that. Mr. Rudolph has already said everything else to be said about the impacts. So we need to monitor to be able to determine the concentration, the sources, and the impact. That's the first thing that we need to do. What does it involve? Air quality monitoring involves real-time data, sensor-based monitoring, and regulatory compliance to ensure air pollution levels remain within safe limits. That is what monitoring is all about. Okay, this is a sensor. Maybe this a sensor base. Inside you have better. Okay, let's see what monitoring is all about. Okay, so this is a sensor-based monitoring. Now, I think about a week ago, I placed this sensor was in the room, and then I was looking at it. Air quality was fluctuating. It reached a time, it reached 300. The air quality index was 300. What does that mean? Air quality of 300, what does it mean? Very unhealthy. And then, do you know what I did? I saw that behind the house, they're burning something, and they were entering the house. So from knowing that, the air quality they have to pinpoint the source. Right, this thing says that you need like 2 minutes to initialize. It says that particulate matter 2.5 in this room is 18.1 micrograms per cubic meter. The standard that Rudolph gave, what is that? Anyway, this one is hours. It's not like 24 hours. But is it safe or not safe? That PM 2.5. PM10 is 29.9. Okay, so that is what air quality monitoring is all about. Now, what are the methods? These are some of the methods of monitoring the air, of that process that we said. There's continuous air quality monitoring stations, fixed station using advanced instruments to measure air pollutants in real time. Mostly these are what they call reference grade sensors. Reference grade sensors, we don't have any in Cameroon. I don't know, Melissa, do you people have a reference grade sensor?
Sorry?
Do you people have a reference grade sensor?
Almost.
Almost, okay. They are almost getting in. But there's no reference grade sensor in Cameroon. Another way of monitoring is low-cost sensors, portable, affordable devices used for community-based. Like example, this one. These are low-cost sensors. Low-cost is actually I was in the UK on an air quality conference, and I realized that these things are not low-cost. Maybe for a normal Cameroonian, because for example, this sensor comes with subscription-based to access the data platforms. There are other devices, but this one, how much do you pay? $200 per year. So if you, for example, you have a project, a 5-year project, and you just get maybe funding for 1 year, after that, what happens? You need to subscribe to their dashboard to be able to access the data. But that's what we call low cost. It's a term from the West. Melissa will tell us later why from the West. That is another way to monitor. Then there's also satellite-based monitoring. Use remote sensing technology for those who are into this. There's passive sampling, and there's mobile monitoring. There are devices that you put on, maybe on bicycle when you're riding cars. Maybe you go to, if you want to map out the pollution source in a particular area, there are mobile devices that can be used. They're mostly put on bike riders, taxis, mobile. So they walk, when they are riding around, they can trace the pollution level, and it gives a map of how the city or that area is polluted. But like I said, air pollution is so dynamic because it depends on atmospheric condition, weather, and weather condition changes a lot. That's why people do modeling, anything modeling related to air quality, they need a lot of maths, solve differential equations. Because the atmospheric condition changes, like for example, now it's windy. 5 minutes after you can see storm coming, right? So it changes. So sometimes when you factor that in. So these are some low-cost, what are monitors are these? These are low-cost sensors, what they call low-cost sensors. I don't know the one Melissa they have, but these are some low-cost. They use AirSense. Which monitors do you people use?
Low cost.
No, which?
Okay, the brand.
Yes.
Attitude. It depends. Personal, like for personal measurement.
It's attitude.
Yeah, you have also last cards. And now for like outdoor measurement, you have Equitian, you have Purple S.
But which one do you use?
All of them.
Okay, you use all of that. Okay,
Yeah.
that's good. So this, alright, these are just some low-cost sensors like that one there. Anyway, this one is it has a sensor is inside. It has it's a technology. It functions based on some scientific technology. So the sensors are inside there. I'll not go into that. That one will be another thing for the future. Okay, what kind of monitors? Maybe reference grade are very big, expensive. For example, reference grades can cost about $50,000 US, right? A reference grade that costs $50,000 US, that would be like. So reference grade monitors are used by mostly government institutions to be able to set standards, and these limits that we have talked about. That's why it's $50,000 US. It's about 27, 28, 30 million for one monitor. And there are countries that have more than 500 reference grade sensors. So it's actually an investment on the head. When you see the research, these people they put money where they put their money where their mouth is, because they know that affect life. Honestly speaking, air quality affects everything in this world. I've read a lot of papers. I say affects pollination. I saw a paper that poor air quality affects pollination in Thailand. We don't know if it affects that cocoyam. There's one time cocoyam was getting bad in Bamenda. We don't know if it is air pollution. You see, right? It could be. We saw the statistics for Bamenda was worse than Yaoundé. So who knows? That's why research is very important. Now, how is air quality monitoring applied? These are just some application of all these things that we are doing. Public health protection. Very important. Public health people. It's very important. Urban planning and policy. Maybe these things are generic, but these are things that when people are going into these areas, they know that they can get maybe jobs in things like this. Climate change research. We have mentioned that some of the pollutants are greenhouse gases, right? Like methane. They mentioned methane. So climate change, industrial compliance, community advocacy. Most of these low-cost sensors is for community advocacy and citizen science programs. Let me say one thing about the WHO air quality guideline that Rudolph presented. I just took one. Listen. Then what are these guidelines? They are standards that set same limits for pollutants. We have already said that. For example, we said that PM 2.5 should not exceed 5 micrograms annually. And I think I did not put that, but I saw that this Rudolph also put that there. For example, if you look at global standards and national standards, this one is set globally by WHO. National ambient air quality standards, these are country-specific air quality regulations. Unfortunately, Cameroon does not have, but there's one country in Africa that has, that I know of, that is functional, South Africa. South Africa has a national ambient air quality standard, but Cameroon does not have. So they are country-specific. From global standards, the countries can decide to set their own limit. Because every country is at different stage of it's 20. China is 35. India is 50. What can you make? Is there countries that are in development, they have a higher air quality, they have a higher limit. Because it means that their stages of development is different. South Africa has a lower than China and even South South Africa and India, you see that South Africa, regardless of the fact that they are advanced than a lot of countries. I was doing a study, and South Africa, for example, I needed air quality data for 30 years. The only country Africa that I could get was South Africa, and was Cape Town. So Cape Town had air quality data for 30 years. So you can imagine, so South Africa is advanced, then this is maybe 24-hour limit. Like we said, Cameroon and most African countries, they have no official standard. But Cameroon has adopted WHO standard. But recently I read a document that said they're developing a national standard. I don't know how they want to develop. But whatever they are developing, we'll see it. It's okay. So I know this is a lot that I'm giving. Let's go now to test your knowledge and win prizes. First question. The prize is water. What is the primary unit used to measure particulate matter 2.5 in the air? A. Parts per billion. B. Micrograms per cubic meter. C. Parts per billion. D. Milligrams per liter. Don't say I don't know. Don't you want to win prize? B. What is B? Micrograms per cubic meter. Who can give me an example of a pollutant that is measured with parts per billion? That a common pollutant that you mostly see the parts per billion as a unit of measurement. No, dust is particulate matter. So is this one NOx? NOx, and nitrogen dioxide. Mostly see P, this thing, and then parts per million. Carbon dioxide, part per million, carbon dioxide. All of us are climate activists. Always hear someone who died his date of birth. All these activists, my date of birth is 390 parts per million. Has anyone ever seen it on social media? If you notice, climate activists in the West, they say born at 390 parts per million. They took the year that the concentration of carbon dioxide was 390 parts per million. You learn something new. You don't hear anything yet. If the air quality index value of a city for a city is 180, how would the air quality be categorized? You people should not say that I'm wasting my time in it. I'm wasting my time. I clean air initiatives and us are wasting our time. Good, moderate, comparing, hazardous. Good students. You cannot remember. I'm not familiar. I can show the chart. Remember, it's 180. Let's go back to the chart. $180. Where does 184? The column. Yeah, the column. Here. Second slide. Yeah, definitely. The next question is this one. Which of the following organizations sets global air quality guidelines? World Health Organization. Normally, this thing, most countries have their EPA, Environmental Protection Agency, but when you hear this, is like that of the US. EPA is normally that of the US. But actually, air pollution really made significant, became a public concern in the US and in the UK because of the smog of 1976. that was in London that killed, I think, 4,000 people in less than a few days. And then the US was the first country in the world to pass a Clean Air Act. That's the most comprehensive policy on addressing air pollution. So it's like they've set the standard, though the current administration is trying to do what they are doing. So it's actually the World Health Organization. They are the ones that set. So the European Union set for the EU. World Health Organization set globally. EPA for the US. We have talked about national ambient air quality standard. So the EPA can set the national ambient air quality standard for the US. We don't have an environmental agency in Cameroon. Might have said maybe the Cameroon Environmental Agency. Who said, what's the meaning of IPCC? Don't answer. She should not answer. Yes, ma'am. Intergovernmental panel for climate change. Okay, you can go ahead. The next question. Which of the following is not a method of air quality monitoring? You've seen a method here. The first is satellite-based monitoring, passive sampling, mobile monitoring, sound level monitoring. Doctor says B, passive sampling.
Which is not.
Which is not.
So it's the sound.
D. Sound monitoring. Question 5, think critically. A factory in a city, assuming that that city is Douala, emits 250 milligrams per cubic meter of sulfur dioxide, exceeding the legal emission limit of 200 milligrams per cubic meter. What actions can be taken to reduce its pollution levels? You see that the standard, the emission limit is 200. And we said emission limit is maximum allowable limit. It's 200 milligrams. But it's emitting 250. Means that it's already 50 more than the limit. So what actions can that industry take? The first thing is you need to look at the source of the pollutant. Where can those sources come from? So an industry, how can they control sulfur dioxide? No, we don't need to think. I think in 1 minute. For me, the first thing I'll think about is that if it's sulfur dioxide, the first thing is that it's not a technology that can control the emission. That's the first thing. And mostly, technology that is used for removing sulfur is called scrubbers. Anyway, it depends on the industry. So it's just, that was just for us to reflect. So probably it means that their technology have a fault. Either they need to upgrade it or completely change it. So imagine if there's no limit, no industry will not be doing anything that they want, right? Imagine that you are working for maybe a power plant company and there's no limit. And then because there's no limit, your machine is giving 250, there's supposed to be 200. You don't care. You don't care because there's no limit to follow. You see why emission limits are important? If they're not there, industry will do whatever they want. That is what emission limit. So these are some of the possible solutions that I thought of. They can transition, because sulfur dioxide is also comes from energy, from the source of energy that they use. They can be using coal, and sometimes sulfur dioxide comes from coal. So they can transition to cleaner energy sources, implement strict regulations and fines to make sure that they improve air quality. So this one now is the government that can do this. This one is at the level of the company. This one is at the level of the company. This one is at the level of the company. And it can also be at the level of the government. Because government ensures compliance. And to ensure compliance, you need to monitor. Because you don't monitor, you don't know if they're exceeding the limit. So that is what is important. So you see that different stakeholders need to come in to ensure compliance. What can civil society do? Maybe us here. Maybe we have some sensor, an outdoor sensor in some our building, and it gives us a spike in air pollution, and we are able to identify that source, that this is the source of the pollutant. And we are able to come up with some strategies and all this. I know that they will say something about maybe advocacy and all that. So when it comes to solutions, every stakeholders are there. Civil society is the watchdog, teachers, everyone. Because at the end of the day, if we cannot just do this ourselves, then people cannot do it ourselves. People do those research, but we need to be able to break down the research for people, for the public to understand. So that was my last and final slide. Another body. But this is one thing I envy. Air quality is more than numbers. It's the key to our health and future. What we measure, we can manage. If we measure, we manage. What we regulate, we can improve. Thank you so much for listening to this.
Bien, ok. Comme Alexandre a dit, moi je vais parler en français, mais néanmoins on se va pas mal en anglais, c'est un anglais. Donc comme il a dit, la plaidoyer, c'est advocacy, campagne, c'est campaign, changement politique, c'est politique change. Ok. D'accord, donc ici, le domaine de la pollution de l'air. Je me rappelle que nous on avait fait ça à l'école. Et quand on faisait ça à l'école chez nous, on avait une enseignante là, elle était doctorante. Quand elle venait en classe, elle s'asseyait dans son coin, elle parlait. Nous, chacun avait son coin aussi. Donc on la regardait là, on s'amusait et tout, on disait, bon, quand elle va venir parler, elle dit ce qu'elle a dit, elle parle. Parce que vraiment, on se demandait à quoi ça allait nous servir à l'avenir et tout. Donc, quand on dit la pollution de l'air, c'est un domaine vraiment hyper technique d'abord. Maintenant, comment j'explique à quelqu'un l'impact qu'a la pollution, cette pollution-là, sur d'abord son environnement et sur lui-même. Donc, c'est tous ces éléments-là ici. Comment essayer un peu de comprendre de manière générale pourquoi ça renvoie, quand on va parler de plaidoyer, de campagne, de changement de politique. Bon, on va commencer d'abord par le Cameroun. Le Cameroun, vraiment, je ne sais pas. Chez nous, il y a tellement de choses. Si vous regardez au niveau de la législation au Cameroun, c'est-à-dire quand on regarde au niveau des politiques, il y a tellement de données, mais qui sont assez vieillissantes, c'est-à-dire en termes de date. Je n'ai pas voulu rentrer trop en arrière parce que les données là, ça ne serait plus bon par rapport au contexte de maintenant. Je me suis arrêté par exemple à cette circulaire-ci du ministère des Finances, datant du 28 décembre 2016. Portant sur les établissements publics, les collectivités territoriales, les organisations de subvention et autres, particulièrement sur le domaine du transport, parce que c'est exactement ça. Puisque quand on regarde la pollution de l'air, pour commencer à étudier un domaine, il faut regarder d'abord quelles sont les causes. C'est-à-dire la pollution de l'air est causée par quoi? Quels sont les secteurs qui sont causes de la pollution de l'air? L'un des plus grands secteurs, c'est le secteur des transports. Vous avez vu cet intérêt particulier de cette circulaire-là. Parce que le secteur des transports est un secteur vraiment cause vraiment de la pollution. Après ce secteur, il y a aussi le secteur de l'agriculture. Vous allez vous demander pourquoi. C'est vraiment pertinent de comprendre que même le secteur là, c'est un secteur grand pollueur en termes d'émissions de polluants dans l'air. Donc, je me suis intéressé à la circulaire pour montrer exactement que on a ici les termes. Vous avez vu là par exemple véhicule, on a tracteur agricole. Donc, vous voyez qu'on s'intéresse beaucoup plus au secteur du transport et au secteur de l'agriculture pour sortir à cette circulaire-là, donc qui pousser dans les acteurs du domaine à faire tout et tout. Parce que c'est exactement les véhicules. Que vos véhicules-là, rassurez-vous, vous n'allez pas utiliser durant une longue période. Essayez un peu de faire que quand un véhicule, après sa durée de vie, vous arrêtez. Donc, chaque véhicule a une durée de vie. Vraiment, aller au plus de 10 ans, les 20 ans, c'est pas possible. Donc, c'est cet élément-là que la circulaire essaie d'expliquer ici de manière ramassée. Donc, je ne vais pas lire tout le reste. Bon, ça rentre également dans les détails de la circulaire. Autre chose, c'est un élément également que j'ai vu, comme je te dis, moi je me suis attardé sur les aspects récents, c'est-à-dire les aspects récents de la régulation au Cameroun. C'est le décret, ce décret-ci datant du 23 août 2011, les modalités de protection de l'environnement de l'atmosphère au Cameroun. Bon, maintenant, quand vous allez cliquer, ça c'est un document, moi j'ai partagé, c'est pas Harrison, je vais partager avec tout le monde. Voilà, quand vous allez cliquer dessus, vous allez avoir accès au document. Quand vous avez vu le document, vous allez voir que le document n'est pas assez explicite. Bon, mais il faut quand même une base. Quand on dit souvent qu'il faut travailler dans un domaine, il faut une base. Le document donne simplement les aspects sur les polluants, les industries de pollution et tout et tout. Donc, quand vous allez donc cliquer sur ce lien, vous aurez donc accès à ce document-là qui vous va donner les modalités de protection de l'atmosphère au Cameroun. Ça, c'est ce document. Bien. Maintenant, moi, je suis allé sur les deux. Comme je vous ai dit, il y a tellement de documents sur la réglementation, sur la pollution annoncée au Cameroun, mais qui sont tellement différents que moi, je me suis attardé sur les plus récents, qui sont mieux, en fait. Parce qu'il y avait également la loi cadre de l'environnement de 1996, qui est également aussi un aspect à l'intérieur qui parle de la pollution, de l'air, la pollution atmosphérique. Mais la date, elle est assez lointaine. En fonction du contexte dans lequel nous sommes, ce n'est pas vraiment pertinent. Bon, pour moi, particulièrement, ce n'est pas pertinent de rester focus dessus. Bien. Maintenant, après avoir fait un aperçu, on essaie un peu de voir un peu quel est le rôle des politiques dans la lutte contre la pollution atmosphérique. Moi, je me suis concentré beaucoup plus sur le Cameroun, puisque nous sommes au Cameroun. Bien. Je ne sais pas si tout le monde est au courant que le Cameroun a rejoint en 2022 le Climate and Clean Air Coalition. Je ne sais pas si tout le monde est au courant de ça. Si tout le monde a cette information-ci. Bon, ça c'est encore une autre problématique qu'on a chez nous, c'est la problématique de l'information. C'est-à-dire, on ne peut pas faire un TikTok où on parle de ça. C'est-à-dire, quand on est un TikToker qui nous parle de choses comme ça, mais on peut faire un TikTok sur quand une moto s'est renversée là, tout le monde commence à reprendre tout ce qui va se passer, qui s'est passé. Donc, le Cameroun a rejoint le Climate and Clean Air Coalition en 2022. Ici, là, on va s'intéresser à la revue littéraire. C'est-à-dire qu'il faut d'abord faire la lecture. Il faut d'abord lire, comprendre d'abord les concepts avant de s'intéresser au domaine. Parce que je peux finir d'expliquer là. Si tu fais 2 semaines sans t'intéresser encore à ça, il va falloir que je reprenne encore toutes les explications pour dire ça renvoie à ceci, ceci renvoie à ça. Donc, nous sommes juste là en train de faire ce qu'on appelle une revue de la littérature pour comprendre même qu'est-ce qui est fait sur le plan local en ce qui concerne la pollution de l'air, qui est une problématique environnementale assez importante qu'il faut prendre en considération puisqu'elle a des impacts sur l'homme et sa santé et sur son environnement de vie. C'est pour ça qu'on s'intéresse à cela. Donc, comme je disais, à chaque fois qu'on définit un plan, le plan a ce qu'on appelle ses objectifs et dans les objectifs, donc pour atteindre les objectifs, on fixe ce qu'on appelle les activités. Donc là, pour l'objectif là, pour les objectifs là, c'est les activités qui ont été fixées. Et comme je vous dis, au Cameroun, tout est référencé. Ça, c'est une particularité chez nous. C'est vrai qu'on est quand même ordonné quand même. Il y a la référence du projet toujours. À chaque fois que ce sont les projets à vocation, financement internationaux, chez nous, au Cameroun, on fait toujours l'effort de tous les référencer. Donc, le projet en lui-même est aussi référencé. Next. Bien. Par la suite, il y a ce qu'on appelle comment donc maintenant nous, en tant qu'acteurs de la société civile, ou alors en tant qu'activistes, moi je sais pas pourquoi je n'ai pas utilisé ce terme-là. Donc les acteurs de la société civile, qu'est-ce qu'on peut faire pour contribuer à avoir une air pure? Comment on fait pour atteindre cela? Je commence par community mobilization, c'est-à-dire la mobilisation communautaire. Pour mobiliser, il faut définir, il faut d'abord commencer par quel est le défi qu'on veut relever. C'est la première étape. Parce que pour mobiliser les gens, par exemple ici chez vous, comme dans la salle-ci, pour vous mobiliser, on a sûrement un défi qu'on s'est lancé pour vous mobiliser. Deuxièmement, on a fixé une stratégie pour vous mobiliser. Ensuite, on a été créatif, c'est-à-dire qu'on a trouvé les termes qu'il fallait pour que ça vous intéresse. Parce que pour quelqu'un qui n'est pas dans le domaine de la pollution de l'air, vraiment, quand tu lui parles de ça, il te parle de la faim, vraiment, il n'y a pas d'eau, il n'y a pas d'électricité, il y a des moustiques, donc c'est compliqué. Ensuite, il y a la partie de la campagne, le contenu de la campagne. Qu'est-ce que tu dis à l'intérieur du panier, ce genre? Imaginez vous partez dans un quartier de Douala, les quartiers au vieux Douala. Comment vous allez faire une mobilisation communautaire pour la pollution de l'air? Vous allez dire aux gens, bonjour, on est venu chez vous, que vous soyez parmi nous, qu'on descende sur le terrain, sensibiliser. 7 h du matin. Donc déjà, bon, toute la nuit, les moustiques. C'est ça que les quartiers de Douala, les moustiques sont costauds ici. Et que quand quelqu'un démole là, tu as les modèles directs. Donc, il n'a pas mangé le matin. Bref, il faut bien que tu donnes un contenu. Ensuite, tu dois fixer donc l'impact. Quel est l'impact que tu recherches? Actuellement, c'est quel est l'impact que nous recherchons dans la télé que nous sommes en train de faire actuellement? La base, c'est d'avoir partagé la connaissance. Si on réussit à le faire, c'est-à-dire qu'on a réussi à avoir un minimum d'impact. Parce que le partage de connaissances, je dis que c'est un domaine assez technique. On partage d'abord. Donc là, moi, j'ai voulu faire les grandes présentations, avoir les grands titres, les photos et tout. Mais je me suis dit, ok, je m'intéresse plutôt à partager l'information avec tout le monde, que tout le monde puisse d'abord lire et comprendre. Quand je parle de mobilisation communautaire pour une aire pure, qu'est-ce que je fais? Je prends donc un exemple. Je vous partage dans le lien d'un exemple. Que vous-même, vous cliquez dessus, vous le lisez. À l'intérieur, vous allez voir que tous les éléments qui viennent ici en haut là, on a détaillé ça à l'intérieur ici. Vous avez tous les éléments. Parce que je pense que c'est un cas d'une organisation en Afrique où ils ont fait une mobilisation communautaire dans le cadre d'une aire pure, une campagne. Voilà. Ils ont mis une campagne dans le cadre d'une aire pure. Donc, vous pouvez donc lire le contenu. Bien. Maintenant, lorsqu'on parle également aussi de mobilisation communautaire, on a ici des termes comme les leadership et les plaidoyers, c'est-à-dire comment ça se passe. J'ai pris le cas du Climate and Clean Air Coalition. Je pense que c'est l'une des plateformes qui s'intéresse beaucoup plus dans le secteur. L'une des plateformes, il y en a assez, qui s'intéresse beaucoup plus. Il faut vraiment ouvrir cette plateforme-là pour vous intéresser, comprendre comment ils font dans le cadre du leadership, dans le cadre des plaidoyers, c'est-à-dire ici, en leadership, comment ça se passe chez eux, comment ils procèdent. Pour arriver, ils sont fixés d'avoir un objectif, la plateforme a un objectif d'abord, ensuite, ils sont fixés une mission, et maintenant pour réussir dans cette mission, donc, ils ont fixé donc, des bases. C'est ce qu'ils ont fait là. Donc il faut vraiment vous intéresser à la plateforme, parce que ils ont vraiment un grand contenu dans le domaine, ils sont très avancés.
Okay, I just also wanted to mention something, sorry Steve. This Climate and Clean Air Coalition is actually a program by the UN Environment Program. So it's a UN agency program and a lot of states have come together to address short-lived climate pollutants. That we just mentioned. An example of a short-lived climate pollutant is methane. Nice presentation.
on air pollution and to monitor and analyze air quality, to determine the effect of air pollution, like to each and every member of the community, and to take actions and strategies. So if we were, I'll put myself in an example, if I'm standing before a certain board of directors and I'm supposed to like talk to them, and I'll be like, you sitting here, you have money. You have your money, but you are taking in, we are breathing contaminated air, and the contaminated air is affecting you in such a way that it's going to shorten your lifespan that you don't know, and you don't have that time to enjoy this money. So why don't you come and then let us invest more and make the population to understand that this air that we are breathing, we have to clean it so as to, for us to have a longer life or something. So what way, how are we going to do this? We can like tell them, let us sensitize these people. They should avoid things like burning of dirt, and inappropriately disposing of certain ways that will promote methane. And we should, I don't know if you understand what I'm trying, the point I'm trying to make. Also, we are going to ask the directors to buy the sensors and monitors that you propose to us here. It's going to make them, and we are going to teach them on how to use these sensors, so that they can, if they have it, they can then know that this is the kind of air we are breathing at a certain given time. And that's all we have to come up with.
Thank you very much.
Arrête encore. Faire le lobby même sans rien écrire. C'est-à-dire, il parle, il explique, on comprend. Le problème avec le lobby, c'est que c'est la manière dont tu t'exprimes devant la personne. C'est-à-dire, moi, on peut avoir le même sujet. Toi, tu parles, tu sors, tu es fâché. Moi, j'entre dans la même salle. Je parle, est-ce qu'on a appelé les gens à renfort que venez soutenir le Cassis? Il a dit quelque chose d'intéressant. Alors que toi qui étais parti avant moi, tu as dit la même chose. Mais la manière dont tu parles, on a l'impression que le gars, c'est peut-être qu'il est en train de jouer, bien, jogging, je ne sais pas. Donc, voilà votre concept. C'est celui-là. C'est-à-dire, air pur dans la communauté. Il défend et il vote un budget. Il dit que son budget pour le projet, c'est 30 000 $, un truc comme ça. Bon, maintenant, tout est le contenu. Moi, je peux commencer ma phrase en disant, Seigneur, est-ce que vous savez que d'ici 10 ans, là, vous tous qui êtes assis là, vous tous là, vous allez mourir d'asphyxie. S'il y a le taux de CO2 dans la vie, c'est la magie. J'utilise les termes qui choquent. Vraiment, attends, tout le monde arrange sa veste. Mais qu'est-ce que le Cassis me raconte? Qu'est-ce que c'est, il y a quoi? Et mon entreprise que j'ai mis sur pied, ça va 2 ans là, c'est comment? Non, ça va, il n'y aura plus rien. Tu vas vendre à qui? Tu vas vendre à personne. Donc moi je décide donc que dans ta politique la politique environnementale de l'entreprise, la politique sociétale, on appelle ça, d'inclure donc à l'intérieur un budget spécifique qui sera donc de soutenir toute activité de lutte contre la pollution de l'air. Et donc par conséquent, donc, voici ce que je te propose. Je te propose que, objectif, donc moi j'ai listé mes objectifs. Il faut ceci, il faut ça. Et comme je veux dire, c'est un concept nouveau. On apprend ensemble. Le départ est bon. Maintenant, il faut juste améliorer le contenu et la prestation. Parce que le thème que je cherche, la prestation. Merci.
On clean air. So we have a plan that started with the objectives, the targeted programs, the key message, the strategy, the budget, the timeline, and the sustainability. And we conceived 2 objectives. objective number one is to create awareness on the necessity of clean air, and the second is to propose preventive measures onto the solution, our solutions. So we say our targeted audience, we are going to target the entire public. So we must probably limit it to a single group of people, just everyone. And how are we doing that? We are going to do that by probably broadcasting or sending out some key messages. The first is we are going to define what clean air is as a first way of raising awareness. Probably so many people don't know anything about it. So we are going to define it to the people. And we are going to bring out the measures or how clean air is, what are the various ways by which we can clean, what are the various ways that we could get to that, and we look at the different types of pollutants, giving their examples. So after doing that, we decided that we need a strategy. Since we are going on a campaign, what are we going to do? We are going to visit schools, marketplaces, jungle groups, and so many other areas. So we meet them. We are moving with leaflet, flyers, and many other ways. In this measure, we are going to probably present what we have. And we went further to look at strategies, visit schools. Again, we are going to use the media. We use the radio, the TV, social media, and any other method that we are going to use in order to send our information to the audiences. We are targeting the general public. And we are going with flyers and leaflets. It means in any direction that we venture, we share flyers and leaflets. And then budgeting, because to have these flyers and everything, we need a budget. We did not bring out a specific amount of budget that we are going to use probably because we have not planned for anything. But it is going to be done by membership contributions. And then away from that, we just need to a timeline, because it has to be smart. When are we going to attain that? We probably say in 3 months' time, we should be done with that. And sustainability. How are we probably going to keep this fire burning? Now, we are going to probably, in every month, go back to the media in order to remind the people to be conscious about clean air. And the equally thought that we are going to create a mobile app that talks about everything that concerns clean air. Everybody can subscribe to this mobile app. Everybody will download it, send it on app phone and app store, whatsoever. You can download it and install your phone. And through the concept of how it is being designed, we are going to probably get information about clean air once and time again. That's what we, the school members, thought.
Maybe another person should also represent it.
Yeah.
Marilyn. Courage.
Good afternoon once more. I'm presenting on behalf of Bonaberi, and we are trying to see ways or means by which we can develop, we can carry out the means of advocacy, so as far as air pollution is concerned. So talking about social media, we have to first of all understand that there are several different social media platforms, talking about TV stations, radio stations, Facebook, TikTok, newspaper, and so on. So talking about TV station, we tried and we saw that we can use TV stations and maybe organize shows, interview from experts, podcast with those who have suffered from the effect of this pollution. Like maybe we can interview the states on how they can try to develop strategies to mitigate this issue of air pollution, and equally interview some community members which have been affected by this air pollution, maybe on the platforms, on show, which can those different ways could be done using TV channels. Equally, talking about the radio station, we equally organize shows whereby maybe we publish a particular phone number, we try to communicate, can maybe create a particular time, and then we try to communicate with the community members, they give their experience and the effect of the air pollution in their different communities. We compare and we discuss that on the different radio stations. And then the next thing too is Facebook. Sharing and engaging contents, like creating contents on Facebook on clean air by promoting inspiring actions via official pages, like creating pages, creating websites on Facebook, creating content, like individuals could create content in relation to this air pollution and posting them on social media and so on. We also have TikTok, creating content also on TikTok, like different ways by which you can mitigate those air pollution. Maybe creating content, like making short videos on TikTok, like in the form of a competition to see the highest viewers, the likes and the rest. Also, talking about newspaper, also try to carry out data analysis on the different environment which have been highly polluted, and we publish it on newspapers. That also be used as a means by which you can create awareness in relation to those air pollution. And after all of this, the main thing we need to know is how to evaluate the outcome of these different social media actions which we have carried out. And one way of evaluating this outcome is maybe know the number of shares. Maybe you share a post, if you carry out a competition on TikTok or on Facebook, you maybe try to analyze the number of viewers, the number of likes, and the rest. Okay. Try to also check the number of participants. Like maybe you can organize a show on the TV channel, maybe publish the number, the call, to share their experience as far as the air pollution is concerned. From there, you can analyze the number of individuals which have called that particular radio station to maybe share their experience as far as the air pollution is concerned. We also have yes, this is one of the most important points also. Try to make an advertisement on the particular equipment which could be used to measure the air pollution rate. You can make the advertisement on radio stations, on TV channels, on Facebook, WhatsApp statuses, and the rest. And then number of feedback from callers on mobile phone, yes. And another one too is like ensuring that they create different websites in relation to this air pollution on the different social medias.
Okay. Bon, okay.
And the messages that we brought were from two thematics. The first is on waste management and green school campus. The very first message that we have is 1 class, 2 trash cans. And the idea behind 1 class, 2 trash cans is that the idea behind 1 class, 2 trash cans is that they will divide them, one for degradable and one for biodegradable and non-biodegradable. So the trash can that will carry just biodegradable waste there and the non-biodegradable. So that's why we have 1 class, 2 trash cans. And then the very second is plant a tree, plant the future. So we plant a tree, plant the future. We have different initiatives. We're going to create a school garden. We'll have an area where children will be under the trees, and trees helps to capture carbon dioxide, and it also helps to remove even waste from the soil. Sunflower has the potential to remove waste from the soil. So the tree also has different capacities to fight climate action. And the strategies in which we're going to promote this to our target group is through social media advocacy, specifically Facebook, IG, and TikTok. We have school campaigns and workshops, so we'll go to those schools, carry out capacity building workshops, and then give them this message that they will carry on as ideas that will inspire them. Then we have pasting quotes in every classroom, so we can go to a classroom and then we do some quotes on the wall so as to keep it afresh in their minds. And then last, we are going to create stickers that can be pasted on their books, and that are the 4 different means that we're going to use to pass on these messages.
4, 2, 3, 1.
Yes.
3, 2, 8, 5.
How many are there?
Not there.
Yes. This is your answer and submit. So 2 people are already submitted. So I'll give us 3 minutes to answer. People that are not yet there.
Are you recording?
We will not wait for you. Alright, so yes, those are the answers. Alright.
Those
so
5 people are submitted.
Yes, just 5 people out of like 20.
Out of 24. So
yeah.
Let's do it. Sharon, you're not submitted.
Maybe I should hide the screen. Some people are answering over here. Yeah. So that's the next question. What is the percentage of oxygen in the atmosphere? So let me just log this. So now you have to feel like
Just submit the answer.
Yes, you have submitted. Okay.
I'm unable to log
So overwhelmingly everybody is yes, 21%.
I think all environmentalists here, I had a lot of environmental engineers here, so yes, this will be common knowledge. And then for the next question.
Wait. Please go back like that.
Okay.
It's 90 meters, I don't understand. Some people are 21% and then 22%.
Yeah.
Those are answer options.
No, but why does it make 22?
Answer options.
This is the percentage of oxygen in the atmosphere. And the answers are 21%, 20%.
I thought there was a number of people responding.
No.
Okay.
No. Alright, so the next question. That's the next question. Right? So what is an example of natural source of air pollution? An example of natural source of air pollution. Alright.
Let's see.
Okay, I think we'll have 12 people, so yes, volcanic eruption, right? So that's the correct answer. At least the food did not really dull our senses. So the next one, give an example of secondary pollutant, of a secondary pollutant. Alright, I'm looking for two people to answer. Is everybody there? No, I think about it.
Yes.
Okay. So that's the answer. So nitric acid. So that's secondary pollutant. So these other two, they're natural. I think he said it, mentioned it, they are natural, they come natural. So those are primary pollutants. But these other ones, when they react to the atmosphere, then they produce nitric oxide. So that's why it's that. So the next one, what is the unit of measurement of particulate matter? He has some about this one here, so everybody should have it. What is in the village and he sold his goods in town. So on this very, very certain morning, he left the village and went to town. Right? He went to town to do his business. So on coming back, as he entered his village, he saw a dead animal at the entrance of the village. So as he moved closer, he saw there was a cow, right? And then he was like, what is happening? So he moved again and he saw a dead goat, and then a dead fowl. And then as he moved closer again, he saw dead people. So he ran out to his house and he saw his wife and children, they were all dead. So everybody in the village were dead. So he was crying, like, he was like, who is the cause of this? What is the cause of this? But in his mind, he was like, there was only one thing that could be the cause of this. Just one thing. This and mind lives in the village. So there was one thing, just one thing. That thing starts with W.
Witchcraft.
Yes. So he thought it was witchcraft. Right? But again he thought to himself, it's like, witchcraft, why would witchcraft attack people and then attack livestock? Right? He had a very, very loud sound like thunder, and then there was a dark cloud in his village. He had a loud sound like thunder, and then there was a dark cloud in the village. This man thought to himself, dark cloud, thunder. He asked himself, did I forget to appease the gods this morning or how? So he definitely knew that it was witchcraft. But days later, the government came to investigate. And in fact, the government found out that later, that very day, there was a landslide in the village. So that village is surrounded by a lake. So there was a landslide in that village. And the lake in that village, it sits on a deposit of carbon dioxide gas. So that landslide that happened, it entered the lake, and that deposit of carbon dioxide was exposed. So that now thunder that we heard was the explosion of carbon dioxide, and then the dark cloud was carbon dioxide contamination. So you can never go to what I'm trying to rephrase. Use the near disaster, right? So a lot of people died, and it was because of carbon dioxide in the air. So in the slide that Mr. Harrison submitted, what was the percentage of oxygen in the atmosphere? In the pie chart that you presented, can anyone remember the percentage of oxygen in the atmosphere? 21%. And then nitrogen? 78. So it means that the other 1% were other gases. So it means that carbon dioxide in the air is not supposed to be that much because it's dangerous, right? It's very, very dangerous. So news reports said that the carbon dioxide level was usually at less than a tenth of 1%, but during that day it was 10%. The concentration of air in that village was 10%. So that was very, very dangerous and killed everybody in the village. So, yes, so that's the Legnios disaster. So the famous location of Legnios, which took place in 1986, right? It was in 1986, and killed a lot of people. So it emitted a cloud of CO2, and a lot of people died by suffocation. So there's no oxygen in the air. You are trying to breathe and you cannot breathe. It's like somebody is strangling you and you die. So, and as I said, it was the usual level of carbon dioxide was a tenth of 1%, but during that day it was near 10%. So this brings me to air quality monitoring, right? My topic was the air quality monitoring. So this was 1986, which means air quality monitoring was not something that people in Legnios were thinking about. So normal, they were living their life, they don't know that they were sitting here, so it felt something very, very dangerous. So it means that during their normal lives, the quantity of carbon dioxide was safe levels, but in that day, 10%. Right? There was no way to monitor carbon dioxide in the Legnios. So that's why these people do not know that they were sitting on this, and they don't know the composition of the air, they don't know the composition of the pollutants, and this happened. So the government tried to rectify this by, I think, embedding pipes into the Legnios, which sends out carbon dioxide in a safe level. So I think this might not happen again for a while. Yeah. So back to my topic, air quality monitoring. So it's the detection of pollutant levels by measuring quality and type, the quantity and types of certain pollutants in outdoor air. So the map that you can see here is the map that we use. We put monitors in these areas in Douala. So in Bonaberi, Makete, Unity, Bodisen, Bonanjo, these 5 areas. We also did had one in Lenti, but it was not really serious. It was not really consistent. That one is not considered it. So why is it? I think that you have mentioned all of this, but why is air quality monitoring important, right? Why is it important? So we are mostly concerned with health. There are many people here with environmental background who are concerned with health. So the first importance was it helped to support research on health effects of pollution, right? So what's the effect of air pollution on asthma, COPD, bronchitis, even diabetes, cancer? Air pollution is related to many illnesses, and air quality monitoring can help them. Once you collect your data, you can help to correlate. During periods of high PM2.5, was the number of observations, did it increase or did it reduce? Is there a correlation? Air quality can help with that. Air quality monitoring can help with that. And then estimation help with exposure risk, right? The person who received cacao, you said mold, right, in the company. So is it related to maybe pollutants in the air? If you collect the data, you can maybe find out. Maybe yes, you can find out. So evaluating source-receptor relationships, see the same thing. And then characterizing air quality and trends. You want to know, during the day, is the air quality bad? During the night, is it good? During the rainy season, is it poor? During the dry season, this is what air quality can help, and the data can help with, right? And then developing and evaluating mission control strategies, right? Like in the Legnios, after they knew that yes, the level of carbon dioxide was high in the atmosphere, they went now to make sure that they released it in safe levels. So this, the collection of air quality data can help with this. Also providing data to run and evaluate models. We are now living in artificial intelligence and machine learning, as you said, right? I think you mentioned here. So air quality data can help with that, right? You do your model, you take many other predictors, and then you add with your air quality data, and you can have an outcome. Maybe you can know if tomorrow will be more polluted than today, or next will be more polluted. So all of this can help with that. So air quality monitoring is very, very important. Yes. So I think you mentioned about this Yaoundé, the clean air article that was done in Yaoundé. Yes, you mentioned a bit. So I wanted to ask you that, what did you guys use to collect the information on air pollution? I think you mentioned a study in Yaoundé that was done in Yaoundé. Okay, it was Rudolph. Do you go collect any data on it?
From the research
That
papers.
was
Okay, from research paper. Okay. So yeah, they said the only air pollution exceeds regulation limits. I think we spoke about AQI and the waste. So it exists, and these were mainly from roads, biomass, vehicles, industry, and they said road traffic was the highest. Road traffic was the highest. There are a lot of cars in Hotel Royale, so this caused a lot of seriousness, right? A lot of air pollution. But it's urbanization. Everybody's moving down, so the population is only increasing. So these things only increase, right? These things only increase, and it's good to have the data back that up. And also, they said there's limited government coordination. There's a lot of when we went to the delegation, I think there's a lot of people who are doing their own data on that, they're doing their own research on air pollution, but it's not joined. Yeah, it's not synergized. Many people are doing it in this country, but the government does not know them, or they are doing it in their own corners. Yes, they are afraid of sharing the data, and there's a lot, but we need coordination. We need coordination. At least this workshop is a great start. But people need to be coordinated. There's need coordination and for that. So, and also they said implementing these clean interventions can save a lot of money, like approximately 224 million, and preventing deaths by 2040. So it's very, very important what we're doing.
Wait, that figure is it for Cameroon?
Yes, for Cameroon. So, if anybody who knows particulate matter knows this diagram. So, if you have ever seen anywhere they say particulate matter, you have seen this diagram, right? So, these are the commonly measured air pollutants that we have. Particulate matter, PM 2.5, PM 10, PM 1.0 as we mentioned, right? And these are tiny particles that can enter the lungs. So, they come from biomass, dust particles, and also domestic activities. Maybe they are cooking, maybe you sweep the house, they increase particulate matter in the atmosphere. As you were saying in the morning, this is PM 2.5, the diameter of less than 2.5. So it's diameter of 2.5 in the air. So your machine that will measure particulate matter will measure the diameter that is for PM 2.5, measure any particular diameter 2.5.
Or less.
Yeah, or less.
2.5 or less.
Or less, right? Or less. So and this is 2.5 and then this is 10. So you see the amount of 2.5 that is in 10. Right? So it's very, very small, smaller, and it's very, very smaller. So this is a strand of somebody's hair, and that's the comparison, and then a grain of sand. So that's PM 2.5. It comes from, these are the sources. And then we also have carbon monoxide from vehicle emissions. So when, and also another source of carbon monoxide is from incomplete burning of fuels. So maybe if you have firewood or you want to start cooking, when you start cooking, the carbon monoxide level increases. When you light the match and yes, the carbon monoxide, yes. So if you have maybe a monitor, you can see that. You can see another very point in that when cooking, the carbon monoxide levels they increase. So other measured air pollutants are sulfur dioxide from industrial processes. We live in Douala, right? There are many industries here. Also nitrogen dioxide, ozone, and then volatile organic compounds. So all these are commonly measured pollutants that we have. So there are three types of measurement devices that we'll be speaking about today. So one is reference monitors, air sensors, and remote sensors. Right? We'll be talking about those today. So for the first one, these are reference sensors. I think you refer to it, reference sensor. So I think the closest reference sensor to Cameroon here will be in the US Embassy in Nigeria.
Yeah.
Yes, the US Embassy in Nigeria, because the US Embassy here does not have. And with the policies that are coming out from America, I'm not sure that they are going to have anytime soon. Yes, so that's the closest reference sensor that we know of. Official, maybe some people have that in their own, but that's the closest reference sensor that we have. So reference sensors are highly accurate, very, very accurate, very reliable, and they need to be in a fixed location. This is very, very huge, very, very big, and it's very, very expensive, like I said, very expensive, and also sensitive. They have a long lifespan, and again, the emphasis on the very expensive. They are very expensive. So a reference sensor can be accompanied with the lab to do maybe measure your samples, right? You collect the samples of a particular material and go to the lab, measure it. That's called gravimetry. You can weigh, you can say, okay, the number of deaths is like this. So I think that's the reference sensor. And then for air sensors, they are low in cost, as in they range like from $200 to $400. They're not too expensive. So they are very, very easy to operate. think we are going to see some of them here. They are very easy to operate. Can measure some air pollutants, not all. They are less reliable as they need to be calibrated with a reference sensor or other sensors. So you have to take their data with it. Yes. So fixed location. They can be in a fixed location, as you can see there, and also they can be ones that you can wear for personal air measurements. They are personal air measurements. They are not as sensitive. Yes. And then the last one will be remote sensing. So these satellites. So you can know the PM 2.5 PM levels from afar from satellites. So there are methods for measuring pollutants at a distance without physical contact. So maybe a map will show like that. I try to give a map can be so. So next we'll move to air quality management, right? So air quality management is the process of monitoring, assessing, and controlling air pollution to protect public health and the environment, which is what we are mainly doing. We are mainly doing the first one, monitoring air quality using our sensors, and then monitoring stations to measure air pollutant levels. Also, we are doing a data analysis to analyze if when there's an increase in the spike in PM levels or a reduction in PM levels. And then we are doing regulation and policy, so we'll be talking to the Ministry of the Environment to tell them that, okay, this is what happened, this is the result that we have, like this. And then implementation of control methods. Mostly we are based now on public awareness. So when people know about something, this can help. We can already go out to maybe change the mind because maybe there is a study that we can do, but public awareness is mostly what we are focusing on, and then public communication, like informing communities about air quality. So we are mentoring students and environmental clubs and also telling them good practices for reducing air pollution. So I've now entered the part of our sensors. So the first one that I want to talk about is our purple air. Purple air. So it measures PM 1.0, PM 2.5, PM 10, and then temperature and humidity. So it measures all of that. So it uses light scattering. So if I were to put this on, I did not come with the charger, but if I were to put it on, it has certain lights here that it will blink every like 5 minutes. So when it blinks, it takes a snapshot of its surrounding air. So it will now record the particles of diameter maybe less than 1.0, less than 2.5, less than 10, and then it will record the mass, right? So it measures. You can set it up to measure every 2 minutes. You can also set it up to measure every 1 hour, every 30 minutes. You can set it up to measure anyhow you want. So it's used light scattering. That's just what light scattering. In a simple terms, that's what light scattering is. You take a snapshot of the atmosphere and then you record what you want. So, if I were to buy this, right? If any of us were to buy this, first thing, there are two options. We can work with it offline, right? We can work with it offline. So here, it has a memory card. It has a memory card. So let me just. So it has a memory card that you can input into it. Once you put the memory card in it and you put it on, once you put it on, it starts recording. Right? It starts recording. So I'm going to pass it around, everybody can touch it so that it's a workshop. So everybody has to, yes. So you just remove the memory card and put it and input it. Just remove it and put it back in. Yeah. Yes. So put it back in and then you pass it to the next person. So that's the first option. If you want to work with it offline, you can use the memory card. But we are living in Cameroon, right? We live in Cameroon that electricity is not guaranteed. So you cannot just work with it offline. You cannot just rely on having the data on your memory card. So another option is working with it online. So if you were to buy that and you want to work with it online, you are going to register on the map. Purple Air, they have a website. So you just go to map the Purple Air. Yes. So this is what the map will look like. Thank you, Melissa. So that's what the map will look like. Right? You see, these are people with their own sensors around Africa. I think it's loading. Okay. It's not the
is linked to long issues. So we are really passionate about long. And so it was founded the answer. In 2018, by this man, Professor Bertrand Bachu, is the DM of Douala General Hospital, and he's also a pneumologist. He's a lecturer. He has so many caskets. That's why he could not be here. But we really represent him. He's really a simple man, and he's passionate about health, and he really wants to improve the life of his community. So he founded Elias, and we focus on raising awareness and we educate communities on many things. So far we have been working with, okay, before going where we work, so this is the support staff that you see. We have Prof, we have Mary, our finance, we have me, I talk a lot so I'm in comes, and you have Raisa, she monitors, as you can see, her monitoring everything, and you have the big boss, the data manager, who is dealing with air quality and everything. So a part of this is the support staff, but behind us we have a lot of researchers. We have people specialized in pneumologists because they are dealing with respiratory health, who are supporting us whenever we are having events. So we have a lot of things that we do, but what we are practically doing in now is transferring the knowledge, because we know things, but we think that if we were aware younger, we could have make better decisions. So why not empowering the younger generation so that they will go faster than us? The idea just came into our mind. We're like, okay, we will start in secondary school. We will monitor environmental clubs. Let them know everything that we know, raising awareness. This is really the sensor. I think she has it. Another one of our members, she's hidden in the in the garbage. She wrote her thesis with Elias. So from that, she was her supervisor, and she got the appliance from Elias. So we monitor environmental club. We teach them everything that we know about air pollution, waste management, first aid, everything around respiratory health. And you can see them. We were doing an exposure on air pollution, and they were answering questions. So with them, what we plan to do, we want to enlarge our network of sensors to schools, because we have realized that, okay, now we are breathing bad air, but you know, when you talk about the general population, it does not really move people. But when you tell parents that this is the quality of the air the children are breathing, don't you think that they will take action? So what we want to do, yesterday we were in the school in Bange installing a sensor so that we now monitor the air in order to have data and go to the government to let them know that, okay, this is what we have. What do we do then? So we are also good at grant writing. We were not lucky, but we were pleased to be selected by the EPIC program. So we are in between many projects at the time. The same team is also working with Clean Air Africa and other research projects. So the EPIC program is from the University of Chicago. Last year in the month of August, they launched an initiative because they have realized that in low and middle income countries, the level of air quality monitoring was so low. Meanwhile, some small information that they were having was high metrics of air pollution. So they wanted to install a kind of air quality network, and they wanted to sponsor people to install sensors in order to have metrics in order to take action. So we wrote a grant and we were selected. So in the beginning, Harrison asked me about the reference sensor, and I say almost. Normally, Douala General Hospital is supposed to have a sensor, like by the end of the year, a reference sensor. Normally. So we write grants, and we are really keen to partner with people to write grants and to make health or public health move forward. So, and we also have partners, because you cannot do anything alone. Nobody is like too talented or knows everything. You need to partner. We were discussing now, and she mentioned something about something that we have never thought about, because you need partnership to evolve and to go far. So before, in this picture, you will see me and my colleague Wu. We were at the delegation of environment before installing a sensor in a school, you need an approval from the Ministry of Secondary Education, and an approval from the Ministry of Environment to attest that the appliance you are installing is not a bomb. Because what you can have a good hack, but let us say an explosion occur. They will trust people that are like, okay, maybe you were doing witchcraft and so you need to have authorization. And during those pictures, we were presenting the air gradient sensor to the delegation, and at the end, they gave us the approval for the installation. So they were really happy. And they are working with, they are looking for more organization to do such a thing. So it's not like a closed, like a hidden information, no. They really want people to come to the light, like people who are dealing with air quality, come to them so that they can check the accuracy of your data and inform also the government and the registration. They are located in Bonaberi Douala. You can go there and they will be happy to receive you. So now, we have talked about Elias. Now, what is your science? You are not waiting for that question. You asked me questions on Elias, right? In the beginning. It's my turn. So in this air pollution, because I feel like we are concluding the day, and I want us not to go back just thinking about Elias has done this or Isaac has done that. I want you to take the thing to your own heart. Like air pollution, you breathe. As long as you live, you breathe. So you cannot stop breathing like, I will not breathe so that air pollution will not concern you. So, what is your role in this fight? Who can help me? I'm running out of breath, so I need to silence myself a bit and breathe. Who can help me? Who wants to say something about his role? My darling friend, yes?
We as the Indian
You're saying something so interesting, but I believe that they are not hearing because of that. Can you increase your voice?
We as an individual need to learn how to manage risk as to prevent pollution.
Manage risk as well as to prevent pollution. Okay. The neighbor?
So I think our role as people who are available for this
Okay, he thinks that our roles is so that as we are coming out of this seminar, we should spread the good news like gospel. Okay, now it's a bit, the answers are perfect and I really like you. Thank you. Now, talking about like you, I want the next answer to be really onto you, the endorsement. What do you think? What do you think that you want to do? Or out of this day, or out of this presentation, what has changed your perception in your mind? Or what do you think that you can do to better air quality? Nobody? I want to say, me, I'll start, and I hope that somebody will follow me. Me, I'm not a scientist. That's something that I'm always joking with my colleague. They are all scientists, but I'm not a scientist. I'm a communication officer. So I was taught how to communicate. And when I came across, like 2 years ago, I knew nothing about air pollution. 3 years ago, nothing about air pollution. I just discovered the field, and I realized that, okay, I'm breathing. My husband will breathe, my children will breathe, so everybody around me that I love will be affected. So I need to take action and to do something. What capacity do I have? I know how to talk. I know maybe expressing myself in front of people. Can I use this in order to better this fight? Exactly. So now that's why I'm doing what I'm doing in the association. So I just want to encourage you to think about your potential. If you're not a scientist, nobody will ask you to go to do science or think about your field and what you have. Like now, as we are talking. For example, we still mentioned something. There is household air pollution too. He mentioned something about cooking and being infected. Maybe in our next participation we can emphasize on that. Do you know that people die out of cooking with charcoal?
Yes.
For example, just changing habits. is already a contribution. So I just want us to think like that, and also to research. So our last slide is this one. There are many small opportunities around air quality and air pollution. It's not just to talk. If you go on LinkedIn, if you search for things, you will see trainings, you will see information where you can be selected, you can do things. There is the Pan-African Thoracic Society, the EPIC University of Chicago, OpenAQ, free training that you can do in order to be empowered and contribute to the fight. So, because at the end of the day, we should remember that pollution will eat you alive if you do nothing. So, that's all for us. Thank you very much.
And all of you for coming. So please take pictures. Cameraman is there. Take pictures without frame. Everyone.